JavaScript. It's one of the most popular programming languages today. Maybe you're new to it. Maybe you've been using it for years. But you can't deny that some of the most important, some of the most widely used software in the world is written in it. But the question is, how well do you really know this surprisingly powerful, sometimes odd, and often beautiful programming language? Welcome to JavaScript, understanding the weird parts. Hi, I'm Tony Alicea. I'm a 15-year veteran of web application development and user experience design, and welcome to this course. This course is on JavaScript. Let's be clear, right from the start. This course is not about making a web page interactive in jQuery or the in and outs of Node.js. This course is focused on JavaScript, the programming language. In this course, you're going to learn how JavaScript works under the hood. We'll delve into advanced concepts. You'll come to understand things that the people that built jQuery understand. And that will make you a better web programmer, a better Node.js programmer, or however else you'll be using your JavaScript knowledge. Perhaps you're coming from being a newer JavaScript programmer, or perhaps you've been using JavaScript for years, or maybe you've been involved in some other programming language and are coming to JavaScript. Either way, this course will help you to understand that JavaScript falsely looks like other programming languages. Languages like Java or C++ or C#. JavaScript is nothing like those languages. It's a different concept, a different mindset, a different paradigm. This course will help you to understand that. And while many programmers learning JavaScript or using JavaScript find some of its elements as they dig into the more advanced features odd or difficult to learn or weird, you're going to find that when you truly understand it, understand how JavaScript works and why it works the way it does, you'll discover that JavaScript is a deceptively powerful and beautiful programming language. And that's one of the reasons why it's so popular. Now that actually leads to my philosophy when it comes to learning code. My philosophy is this: don't imitate, understand. The biggest mistake I think people make in designing programming courses and in looking for programming courses and books and materials is looking for or providing just code to imitate. Now, don't get me wrong. Examples are very important. But examples, parroting, writing down the code that somebody else wrote for you on a screen or on a piece of paper, only takes you so far. As soon as you're in the real world and you have to debug a difficult problem, or you have to start some code from scratch that isn't anything like what you've seen in your examples, you're going to fall down. You're going to have problems. You won't be able to move forward. However, if you deeply understand what the tool is doing for you, and a programming language is just a tool, then you'll be able to debug those hard problems, come up with innovative and interesting solutions, be able to look at other people's really good code and understand it, borrow from it, or enhance it. So in this course, we'll look at plenty of coding examples, but we'll focus first on the understanding, the deep understanding of the programming language, so that then the examples make sense, and then you can use your knowledge in the real world in brand new situations. That said, it is expected that you have very, very basic JavaScript knowledge as you come into this course. So you understand what a JavaScript file is, variables, functions, basic understanding of functions. We're going to dive much deeper into functions through this course, and loops. Just the very basic knowledge a beginning programmer might have. If you have that, you're good to go. So let's get started. We'll dive in, and I think you'll come to appreciate this beautiful programming language, JavaScript, all the more. Let's understand JavaScript. Let's get started. Let's take just a moment and talk about setting up for this course. You'll need two things. One, an internet browser with developer tools. That could be Internet Explorer, Firefox, Safari, or Chrome. In our case, we'll be using Google Chrome. And you'll also need a text editor. I'll be using brackets.io, which is free, and also lets you quickly and easily run web pages in JavaScript code. Now, I know we said this course isn't about building websites or jQuery and that sort of thing, just focusing on the JavaScript programming language. We're going to do that, though, by writing JavaScript code and then running it in the browser and using the browser's tools to learn more and dig deeper into what the language is doing. If you'd like to match up for this course with the tools we'll be using, you'll need Google Chrome again. You can find that if you don't have Google Chrome at google.com/Chrome. Go to that address, download and install Chrome on your computer. Once you have it installed, you'll be able to go to the menu and you'll be able to go to More Tools and then Developer Tools, or you can hit F12 on your keyboard. We're going to spend a lot of time inside these developer tools. They'll probably pop out like this for you, and then you can use this button, if you like, to undock into a separate window and give yourself a bit more space. You can also hold down your Control or Command key and then do plus or minus to increase or decrease the font. I'll be using a larger font size so that you can see what we're doing in the video. Now I'll close this with the X in the upper right of the Developer Tools window. And if you want an excellent text editor, perfect for this course, just go to brackets.io. Brackets is provided by Adobe. It's free, and it lets you edit HTML, CSS, and JavaScript. And the really nice part is you can immediately run it in the browser because it comes with a little server that's just part of the package. Again, this is free. You can go to brackets.io, install it on your computer. Once you do that, you just open it. And as we're writing code in this course, or you're perusing the downloadable code that the course makes available, we'll just go to File, Open Folder, find a folder, say a folder on your desktop or wherever you choose to download these files or work on it, and that will be the folder that contains your code. And then we'll just open our file and begin writing our code. You can adjust the theme under View Themes to change your color scheme or increase and decrease your font size. I'll be using, again, an increased font size for the purposes of the video. And that's it. Google Chrome and brackets, and you're ready to go for this course. Let's take a moment to describe something that we'll do throughout this course, wherever necessary. In computer science, in programming, in all of these fields, there's a tendency to use words that sound a lot bigger and more complicated than the thing that they're actually describing. So every now and again, as we're going through this course, when we're covering a concept or a topic, and it's important that we're using the same vocabulary and that we be understood, we'll drop one of these. Big word alert. When you see that, that means we're about to discuss a word that's probably a lot less complicated than it sounds. When we see that, we'll break glass for emergencies and give the definition and then some more detail and talk about it in some depth. So as we're going through this course, because this is an under-the-hood style course, a course that delves into the details, don't be intimidated by vocabulary. These words, these terms that we may use, some you may have heard before, others you may have not, are not a big deal. We'll stop, we'll discuss them, and then we'll show how they are used, how these concepts are used throughout JavaScript. So remember, it's just vocabulary. A couple of last notes. In regard to this idea of understanding, remember that JavaScript the programming language is really abstracting you away from how the computer works and how the browser works, if that's what you're using to implement JavaScript, or the server that's running the JavaScript. We need to understand how the tool is functioning in order to be able to properly write JavaScript code, deep, advanced JavaScript code. We're going beyond just the basics. So even though it may seem at moments through this course that we're covering something that, oh, you don't really need to know, you'll find as we progress that that fundamental foundational knowledge is going to brighten the path for you, give you plenty of aha moments. So be patient as we go through concepts, because very quickly you'll see just how important they really are. This course is also going to talk about frameworks. One of the best things about JavaScript the past several years also happens to be, in some ways, one of the worst. The open source community has developed a tremendous amount of very popular, very powerful JavaScript libraries and frameworks. Things like jQuery and AngularJS. These things are great, and they help us quickly build some pretty neat and pretty awesome software applications. However, a lot of people are being introduced to JavaScript via these frameworks. Rather than learn JavaScript first, you might learn jQuery or learn AngularJS, and JavaScript kind of comes along for the ride. The problem is that jQuery and AngularJS and all these other frameworks and libraries, as awesome and wonderful as they are just JavaScript code. They're a JavaScript file that you include in your application that provides you a bunch of code that other people, really smart, good developers, have written. But a lot of developers, if they opened up those files, if they opened up that code, they wouldn't be able to understand what's in it, because we tend not to then understand the deeper parts of JavaScript. And that's dangerous. If you want to build a robust, good JavaScript application, you can't just know jQuery or know Angular. You have to know and understand the things that the people that wrote jQuery and Angular know and understand. And so that's what this course is going to endeavor to do, to give you the kind of education, the kind of information that will let you open up jQuery, look at it, look at the source code, and understand it. In fact, at the end of this course, that's exactly what we're going to do, and then we'll try building our own little mini framework or library, just like jQuery and Angular and others have done, using these same techniques for understanding how to structure JavaScript applications and how they work. So that's frameworks. Now, the weird parts of JavaScript have to do with people coming from other programming languages, perhaps you are, and having certain expectations because of how JavaScript looks, and not understanding just how different it is under the hood from most of the mainstream programming languages. And yet its weird parts are often its most powerful and beautiful parts. So when we say that we're understanding the weird parts, what we're really going to do is understand the hows and whys. Also, no programming language is perfect. So occasionally through this course, we'll stop and point out something that's a hazard, something that's a danger, a downside of the JavaScript programming language, or something that you should avoid. So that's it. Understanding frameworks and the weird parts. We're ready to dig in to JavaScript. It's time for our first aside. Throughout this course, we'll have lectures that are asides. That means that we're going to cover something that's just off to the side of what we're talking about directly, but very, very important to understand whatever technique or concept or aspect of JavaScript that we're about to cover. Now, each aside might have a particular type. In this case, we're going to do a conceptual aside. A conceptual aside means we'll focus on a concept or an idea that's fundamental to the rest of the course of understanding and building slowly our knowledge of JavaScript, which is what we're going to do. This conceptual aside will cover 3 ideas: syntax parsers, execution contexts, and lexical environments. These are fundamental concepts, fundamental ideas to understanding the rest of what we're going to talk about, and you're going to see these ideas come up again and again throughout the rest of this course. Now, all three of these are complicated sounding terms that actually aren't that difficult to understand. So we're going to give you your first three big word alerts in a row. All right, so here's our first one. Big word alert. Syntax parser, break glass. A program that reads your code and determines what it does and if its grammar or syntax is valid. So when you write JavaScript, it isn't magically directly telling the computer what to do. You're abstracted away from all of that. You're writing code, but then someone else or other people built programs that convert your JavaScript into something the computer can understand. Those programs are called compilers, and at times they also have to do with interpreters. But those programs, interpreters and compilers, do the process, the work of actually reading your code character by character and determining if the syntax is valid and then implementing that syntax in a way the computer can understand. So when you're thinking about your code, think of it more like this. You have your code that you've written, and there's a program that is going to convert what you've written into a real set of computer instructions, something the hardware can physically understand. So if you have a function with a variable, that function and variable will be represented in memory, but it's being translated from what you're writing, what is more human readable, to what the computer can understand. There's a compiler or an interpreter between those two things, and part of that is a syntax parser. So it's going through character by character, like F-U-N-C-T-I-O-N, and says, oh, that's function, so there should be a space after this. And then the next thing I see up until the parenthesis will be the name of the function, etc., etc. And that gets translated by the systems that someone else wrote. But that also means that in that translation process, if they so choose, the programmers that wrote the compiler can choose to do extra stuff. Your code is not what's actually being given to the computer, but a translation of it. And so along the way, the engine that is interpreting your code can decide to do other things. Those programmers, those guys and girls, could have chosen to do something else. And in fact, that's going to come up as an important element of understanding JavaScript. So that's syntax parsers and thinking about the programs that are actually running every time you run your JavaScript code, that intermediate program that's creating your code. And we're going to see this come up later on. All right, time for the second one. So, big word alert. What's the next big word we're going to cover? Lexical environment. That's a big term. Where something sits physically in the code you write. The word lexical means having to do with words or grammar. So we're talking about the code you're writing, its syntax, its vocabulary. Now, a lexical environment exists in programming languages in which where you write something is important. So that sounds kind of funny, but actually, not every programming language is that way. But remember, we said you might have some code, let's say a function, with a variable inside of it. The variable sits lexically inside the function. That is, physically, the code that you're writing, that's where it sits. But remember, we said that your code is not what's actually given directly to the computer, but it's translated into something the computer can understand. But in programming languages where the lexical environment is important, that means that where you see things written gives you an idea of where it will actually sit in the computer's memory, of how it will interact with other variables and functions and elements of the program. And that's because the program, the compiler, that's converting your code to those instructions cares. about where you put things. It makes decisions. That syntax parser going through everything makes decisions. So when we talk about the lexical environment of something in the code, we're talking about where it's written and what surrounds it. Got that? All right, let's move on to the third one. Our last big word alert. What is it? Execution context. A wrapper to help manage the code that is running. There are lots of lexical environments, areas of the code that you're looking at physically, but which one is currently actually running is managed via what's called execution contexts. And in execution context contains your code, the running code, it's running your code, but it also can contain things beyond what you've written in your code. Because remember, again, your code is being translated, being processed by a whole other feature, a whole other set of programs that someone else wrote. And so it's executing your code, and it can do other things as well. And that's what's happening inside JavaScript. We'll see that very shortly. So lexical environments, we're talking about execution context, we're talking about syntax parsers. Just remember, it's important. We're going to hear these terms and understand them throughout the course, and it will give us a basis to understand what's happening under the hood in JavaScript. All right, let's move on. It's time for a conceptual aside. Name-value pairs and objects. As we talk about JavaScript, objects are incredibly important, and we're going to spend a lot of time on them. But we need to understand what we're talking about when we say an object in regards to JavaScript itself. First of all, we need to understand the term name-value pair. It's quite simple, actually. A name-value pair is a name which maps to a unique value. Now, that name may be defined more than once, but it can only have one value in any given context. Remember, we're talking about execution context. So in any particular execution context, that is a section of code that is running, a name can only exist and be defined with one value. However, that value may be more name-value pairs. Okay, that sounds a little confusing, but all we're really saying is there's a name, and that name is assigned a value, but that value could be other collections of name values. Okay, for example, this is a name-value pair. You've probably done things like this all the time in code. You have a name, a variable, and a value. In this case, address is the name, and 100 Main Street is the value. That's a name-value pair. Pretty simple. Now, when we're talking about objects, we can then use this name-value pair concept to define them. An object is a collection of name-value pairs. That's the simplest possible definition of an object when you're talking about JavaScript. Now, other languages, other programming languages, might have more complex concepts when it comes to objects, but when we're dealing with objects in JavaScript, that's really what they are. They're a collection of name-value pairs. So, for example, I might have a name, and that name has a value, but that value might be a couple of other names and values. And inside that name, that value might be other name-value pairs. And I might have a few of these. So I have a name and a value, but the value might be other lists of names and values, which in turn might have other lists of names and values. For example, the address example we had before that was just a name-value pair, here it's a collection of name-value pairs. Address is a collection of other names and values. Address is still the name, but the value is a collection. Street is and main is a name-value pair. Number and 100 is a name-value pair. Apartment is a name, and its value is another list or collection of name-value pairs. Floor is the name, 3 is the value, number is the name, 301 is the value. That's an object in JavaScript. When we're talking about objects in JavaScript, we're talking about collections of name-value pairs, and that value might itself be another object. So apartment has a collection of name-value pairs, and that's an object. So address, its value is an object. Apartment, its value is an object. You see how they nest down? Don't think any more deeply about objects in JavaScript than this. We're going to see some interesting things you can do with objects, but at its core, this is what an object is in JavaScript. It's just that simple. I know what you're thinking. Are we going to actually write any JavaScript code anytime soon? Yes, right now and for the rest of the course. This lecture is the global environment and the global object. Whenever code is run in JavaScript, it's run inside an execution context. We've seen that word already, meaning a wrapper that the JavaScript engine, the program that other people wrote that's parsing and looking at and verifying and executing your code, that wraps that up, that code that you've written. It wraps the currently executing code in an execution context. So when we look at our very first JavaScript program, we're going to be looking at an execution context being created and run. And the base execution context, we'll look at a few, because there's more than one that runs during a JavaScript program normally. The base execution context is your global execution context. And it has a couple of special things that come along for the ride. The base execution context, the global execution context, and when we say global, we're talking about the thing that's accessible everywhere to everything in your code. It's global. All right, so the global execution context creates two things for you. You don't have to in your code. It creates a global object. Number in objects is just a collection of name-value pairs. It creates this global object, and it creates a special variable for you called this. The JavaScript engine is creating these two things for you whenever your code is run, because your code is wrapped inside an execution context. And these two things are created for you by the JavaScript engine. All right, let's take a look. All right, it's that time. We're going to look at our very first JavaScript program. Now, we're going to run our JavaScript in the browser. This is very convenient, again, because we have our dev tools and we can see what's going on under the hood a little bit easier. But we're going to do that simply by having a simple HTML page referencing a single script I'm calling app.js, which will always contain the code that we're working with. I have this sitting in a folder, and I'm opening that folder in brackets. And then I'm going to hit this button in the upper right in order to launch Google Chrome and run this web page, which will then cause the browser to run this JavaScript. That's how we'll do all of our examples. All right, so are you ready? Here's our very first JavaScript program. Let's open app.js. There it is. What do you think? I know what you're thinking. Hey, that's empty. There's nothing in that file. All right. Well, you're right. I wrote no code. Let's run it. I'm going to hit my live preview button. Google Chrome launches. And then I'm going to open up the dev console. Notice there are no errors. The JavaScript file was loaded. The syntax parser started and realized there is nothing to parse. So I had no code to execute. But because it started executing the JavaScript, because it ran the file, an execution context was created. And remember those two things that were supposed to be created for us. a global object and a special variable called this. Well, inside here, inside the DevTools console window, I can take a peek inside the execution context at the values of variables and what's going on in memory. So if I just go this, look, there's something there. Now, I didn't build this. I didn't put that in the code. The code is empty. But the execution context was created by the JavaScript engine, and it decided what the value of this should be. And what this is the window, the current window that I'm in, my browser window, because I'm running JavaScript in the browser. Interestingly, I have available an object called window, the same object. So this window object, the current tab that I'm on, is the global object inside browsers. Now, if you're using Node.js, if you're running JavaScript on the server, it won't be the window object. There's a different global object, but there is always a global object when you're running JavaScript. In the case of browsers, it's the window. If I had a separate tab open, that would be a separate global object because each tab, each window is its own execution context, its own global execution context. But notice I have these two values and I wrote no code. That's the JavaScript engine doing this for me. So we just learned something. An execution context was created at the global level. There's a global object, meaning that object is available to all the code running inside that window, inside that area, inside that JavaScript file, inside that lexical environment. And there's a special variable that the JavaScript engine created that sits inside the execution context called this. And what we saw was that the global object inside browsers, inside internet browsers like Google Chrome or Firefox or whatever the case, is the window object. And that it did create a variable called this, and at the global level, those two things are equal. This refers to the window object. And you can also just say window and get the global object. Now, just to be really clear, when we say global, in JavaScript that means not inside a function. Don't think too much deeper than that. That means code or variables that aren't inside a function is global. All right, so we already saw that we have window and this, a global object and this, available to us without a single line of code. Now, what happens when we actually put some code in? All right, let's write our first bit of code. I'll create a variable and call it A, and just give it a value. Hello world. And I'm going to create a function called B, and just leave it empty. Got that? A variable and a function. And now I'll run this, and I'll actually have some code. Now, the execution context is created. This code is not inside a function, although I'm creating a function here. All this code is not inside a function, so it's global. This and window are already available to me, and you'll see something interesting. If I look at window and open it up, remember JavaScript objects are name-value pairs, so here's lots of names and lots of values. The function can be a value. But if I scroll down a ways, there, see that? A and B, my variable and my function. In JavaScript, when you create variables and functions, and you're not inside a function, those variables and functions get attached to the global object. So if I just go like this, A, it's hello world. But I could also go window.a, the global object.a. It's the same thing. See that? So your variables and your functions, when lexically not sitting inside a function, They're just sitting right there on the global object. All right, so when code is executed, your JavaScript code is executed, an execution context is created. At the base level, when you're not inside a function, you have a global object that the JavaScript engine creates for you as part of that execution context. If you're running code inside a browser, that global object is the window object. You get a special variable called this. And in the case of the browser, this at that global level is just the same as the window object. It's equal to the window object. There's also something that is something we haven't talked about yet, and we will shortly. A link to the outer environment. Now, when you're running code inside a function, that means the code that's outside the function. But when you're running at the global level, meaning you're not inside a function, well, there is nothing outside. You're as outside as you can get. There's no outer environment, so that's just null. It's nothing at the global level. But we'll see this come up later, very importantly, when running and executing functions. And finally, the execution context is running your code. If you're creating variables and functions, then that's going to sit on the global object. If you're writing code that is global, again, that's not inside a function. But the important thing here is that there is this wrapper, this execution context, which has these other things that you didn't write. And JavaScript, the JavaScript engine running your code, is doing this for you. All right, so let's move on. So we've seen how JavaScript, the engine, is wrapping our executing code in an execution context. But there's an important aspect, one of those weirder parts of JavaScript, that we need to understand. And to understand it, we just need to dig a bit more into what the JavaScript engine does to create an execution context. So this is the execution context, creation and hoisting. To start with, let's look at a phenomenon that happens in JavaScript that people find surprising and perhaps a bit confusing. I have my simple variable here, a, and my function b. I'm going to actually put a line of code in here just so the function does something. I'm going to use console.log. This writes to that console in the tool window in the DevTools in the browser. If you haven't used this before, we'll be using this an awful lot throughout this course. It's just going to output whatever we put in here out to that DevTools window. So when we see called b, we'll know that we called this function. Now, if I was to call the b function, if I was to invoke it, to execute it, you would normally think I would do this. And I can console.log a after that. So what would you expect to see? Well, I would expect to see called b and then hello world. All right, so let's go ahead and execute this. We'll run it in the browser, hit F12 for my DevTools, and look, exactly what we expected. Now let's do something a little different that in other programming languages you would expect to not work at all. I'll go ahead and go back to brackets, and I'm going to move these calls where I invoke the b function and where I output the value of a to the top of the page. I'll save this. Now what would you expect to have happen? Well, in most programming languages you would expect an error, because programming languages execute their code one line at a time. And since we haven't gotten to the b function, I can't use it yet. That's what you would normally expect. But JavaScript isn't like that. When I go back and refresh this page to rerun the JavaScript, look what happens. It ran the function, and instead of throwing an error, it gave me a value, but not the hello world value that I saved, but this thing called undefined. So even though the function was below where it was executed, it still ran. And in fact, this A variable was available to me, even though it wasn't the proper value. Watch what happens if I just remove it outright. So I'm trying to console.log A, and I don't have it declared as a variable anywhere. Now, I actually get an error. A is not defined. But if I put it back, so that somewhere on this JavaScript file I have that A variable declared, instead of an error, I get a value, the phrase undefined. This phenomenon is called hoisting. But the way it's explained, I think, can give you the wrong impression. The way, if you look online, that hoisting is explained is that people say, well, that variables and functions in JavaScript are hoisted or moved to the top by the JavaScript engine as if they were moved physically up to the top so that they work, no matter where you put them. But we can tell that that's not quite right because A wasn't set to hello world. So it wasn't like this line was physically moved. It behaves a bit more like this, as if I had a variable declared and then set the value later. But still, that's really not what's happening, because we already said what's executing isn't what you've written. It's being translated by the JavaScript engine. So it's not like the JavaScript engine is physically moving the code that you've typed around and then executed it. So let's undo all this. Here's the code that we wrote. To understand what JavaScript is doing, we just need to dig a little bit deeper into the execution context and how it's created. The reason JavaScript behaves the way it does, that variables and functions are to some degree available even though they're written later in the code, is because the execution context is created in two phases. The first phase is called the creation phase. In that phase, we know we have the global object, which is set up and in memory. We have this, which is set up and in memory. And again, the global object only referring to when we're dealing with the global execution context. We'll see other execution contexts later. But this is always created inside an execution context. There's an outer environment that's created. And in that creation phase, as the parser runs through your code and begins to set up what you've written for translation, it recognizes where you've created variables and where you've created functions. And so it sets up, in this creation phase, the memory space for the variables and functions. And it's that step that is somewhat confusingly called hoisting. It's not actually moving code to the top of the page. All this means is that before your code begins to be executed line by line, the JavaScript engine has already set aside memory space for the variables that you've created in that entire code that you've built and all of the functions that you've created as well. So those functions and those variables exist in memory. So when the code begins to execute line by line, it can access them. However, when it comes to variables, it's a little bit different. You see, the function in its entirety is placed into memory space, meaning that the function, its name, and the code inside the function that's being executed. However, the next phase, the execution phase, which we'll talk about in a moment, where it actually executes your code line by line, that's when these kind of assignments are set, where A equals something. So the JavaScript engine, when it sets up the memory space for A, it doesn't know what its value will ultimately end up being until it starts executing this code. So instead, it puts a placeholder called undefined. That placeholder means, oh, I don't know what this value is yet. That's the same placeholder that we would have if we never set it at all. All variables in JavaScript are initially set to undefined. and functions are sitting in memory in their entirety. That's why it's actually a bad idea to rely on hoisting in any way. You can run into trouble when you realize that that value is actually undefined and not the value you're expecting. So while this technically kind of works, it's better to always do this so that you don't get caught up in that trap. Now, that said, we understand that when we're talking about hoisting, when we're talking about this scenario where I can call the function even though it's declared later, it really has to do with the fact that what I wrote is not what's directly being executed, but the JavaScript engine is then taking my code and making decisions. In this first phase of creating the execution context, the wrapper around my code being executed, it's going to set up the memory space for the functions and the variables that it sees that are going to be used when it starts executing the code. And therefore, we have access to them in a limited way before they actually physically appear on the page inside that lexical environment. Kind of weird, right? But not so much when you understand that it's just phase one. I'm going to set up the memory space. So when the code begins executing, those things are actually already sitting in memory because it looked at your code and already preset things up to be ready for the code to start executing. It's time for another conceptual aside. We've already talked about this a bit, but it's important enough to delve just a little bit into. JavaScript and undefined. We've already seen that there's this first phase of creating an execution context in which there's a global object for the global execution context. There's a special variable called this, which is always created. There's a reference or a link to the outer environment if there is one. And this phenomenon called hoisting, where variables are set up and functions as well. And in the case of variables, they're initially set equal to undefined. But what do we mean by that? Well, let's go back and make our example a bit simpler. I'll get rid of the function and the function call, and we'll just focus on the concept of undefined. So I'll just take my variable a, declare it, and then log it. I'll go ahead and run this in brackets. And we see the phrase undefined. Now remember, we already saw that if I don't declare it at all with the var keyword, it actually throws an error where it says A is not defined. But that's confusing because isn't not defined and undefined the same thing? Well, no, because when we say, and I'm going to put the var A back, in JavaScript, when we see undefined as opposed to that error, this isn't simply the word undefined, but it's actually a special value that JavaScript has within it internally that means that the variable hasn't been set. To prove that, I'll show you something. I'll do if a, I'm going to do triple equals. Now, if you've never seen triple equals before, we'll talk about that at length later in the course. But this is very similar to double equals, is equal to, but it's a bit safer, and we'll see why later. Just for now, we'll just use triple equals because this is good practice, and we'll explain why when the time comes. But for now, just imagine using triple equals anywhere where you would use double equals. All right, so triple equals, and then I'm going to say the word undefined. And then if it's undefined, I'm going to output a phrase. A is undefined. And then I'll put else. If it's not undefined, I'll put console.log A is defined. Notice that undefined isn't wrapped in quotes. This isn't a string. It's a special keyword. It's a value, a special value in JavaScript. And when I go back and run this, notice that A is undefined. So when this if statement checked if A was equal to this special keyword, this special value undefined, it said yes, it is. If I was to set A up here equal to a value, then by the time we get down here, A is set, and so A is defined. This was false. It was not equal to undefined. But if I don't set the value, again, this will be true, because the initial phase of creating the execution context sets all variables equal to undefined. And if you don't do anything else, that's what that value will be. Notice again, this is different than if I simply never declare the variable var a and attempt to console.log a. When I refresh this, it gives me an uncaught reference error, A is not defined. That's because that initial execution context creation, that creation phase, when it went through, it didn't find a var A, so it never set up the memory space. So when it went to execute this code, it said, hey, I don't have A in memory at all. So it gave you an uncaught reference. A is not defined. I don't have it in memory. That's what the browser is saying. That's what the JavaScript engine inside the browser is saying. However, when I declare var A is placed into memory during the creation phase. So the execution context saw var A and set up A in memory. And so even though I haven't set it to a value, the JavaScript engine, which is doing more than what I'm just writing in my code, already set it to this special value called undefined. So undefined is not like empty or doesn't exist. It doesn't literally not exist. It's actually a value. It's actually taking up memory space. It's a special keyword, a special value that means this is the value that was initially set by JavaScript. And that leads to a little bit of a warning. Never do this. Never set yourself a variable equal to undefined, because actually you can. For example, I could set this initially to hello world, and then console.log it, and later for some reason set it to undefined, and we'll see that it is. Watch. Hello world, and then later it's undefined. That's perfectly valid JavaScript, but it's a little dangerous. It's better to let undefined, that special keyword, mean I, the programmer, never set the value. That will really help you when debugging code. If you make a habit of setting values equal to undefined, then it's really hard to tell if something is undefined because you set it or because the JavaScript engine set it and you never set it to anything else. It's always better to let undefined mean I've never set this value. That's really useful, and it will help you in your debugging. So undefined, this is a special value that is also a special keyword in JavaScript, and it's the value that variables receive during the creation phase. The first phase of creating an execution context sets up the memory of the variable, and in that memory space puts the value called undefined. I would have called it something else personally, like not set, but that's what JavaScript calls it, undefined. And if you don't, in your code, set it to anything else, that's what it will be. Or if you set it something else later and use it beforehand, that's what it will be. All right, so that's JavaScript and undefined. All right, so remember we said there were two phases when it came to the execution context within the JavaScript engine. The first phase was the creation phase, when it set up the variables and functions in memory. And then the second phase is the execution phase. And this phase is pretty simple to understand. In the execution phase, we already have all those things set up that we had before, and now it runs your code, the code you've written, line by line, interpreting it, converting it, compiling it, executing it on the computer into something the computer can understand. And it runs your code line by line. So if I go back to our example that we used for hoisting, and I console.log a here, and I'll just go ahead and move the function to the top so we're using good practice so we don't have confusion. I have a function and I call it. I'm logging a. I'm setting a to equal to a value and declaring it, and I'm logging a again. So what do you think we're going to see? B will be called, then a will be logged, then a will be logged again. We're going to see 3 lines because console.log is also called. So what are the 3 lines? What's the line here? What are we going to see here? And what are we going to see here? All right, let's go ahead and run this, refresh. Did you get it right? It called the function. The first time it called a, it got undefined. And the second time it got hello world. Why? Because now we're in the execution phase. So in the creation phase, we set up this function, and var a was set up and set equal to undefined. And now it begins to execute code. So line 5 is executed and it runs that function. Line 7 is executed and it outputs the value of a to the console. And since a was set to undefined in the creation phase, that's what we see. Then it executes line 9 and sets the value in memory of a to the string hello world, exclamation mark. And then in line 11, it once again outputs the value of a in memory to the console, which is now hello world. So it just executed these things line by line. And we understand between these 2 phases, the creation phase and the execution phase, now why we see what we see and why JavaScript behaves the way it does. It's time for another conceptual aside when it comes to JavaScript. This one is single-threaded synchronous execution. So we have 2 rather large-looking terms, so guess what? Big word alert. First of all, single-threaded. It sounds pretty complicated, but it's easy to understand. That means that one command is being executed at a time. So any program is full of many commands within the code. Single-threaded execution means you're only doing one at a time. Now, when we're dealing with browsers, understand that JavaScript isn't the only thing happening in the browser. So when we say JavaScript is single-threaded, it may not be under the hood of the browser. But from our perspective as programmers, JavaScript behaves in a single-threaded manner. All right, the next one. And once again, big word alert. Synchronous. This is very similar to single-threaded. Synchronous meaning, in the purposes of programming, one at a time. Not 2 at a time or 3 at a time, but one line of code being executed for synchronous execution at a time, and for our purposes, in order. So the code is executed one line at a time in the order that it appears. And that's it. Single-threaded synchronous execution, meaning that in JavaScript, only one thing is happening at a time. Now, I know what you're probably thinking, but hey, I've heard of asynchronous requests in JavaScript, especially on the web. AJAX, the A stands for asynchronous. What are you talking about? Well, we'll see that in just a little bit. But for now, just trust me. JavaScript is single-threaded, synchronous execution in its behavior. All this time, we've been talking about the global execution context and how it's created and executed. But we also mentioned that functions are special in regards to this. Here we'll talk about function invocation and the execution stack. And we're going to introduce this concept that will be fundamental to understanding some very important and advanced concepts in JavaScript. Before we do that, though, we've rather casually used a word here, a word that sounds a lot more complex than it really is. Big word alert. Invocation. That just means running a function or calling a function. So when we say we invoke the function or function invocation, we just mean, hey, run the function. In JavaScript, we do that by using parentheses. You put the name of the function and then put parentheses. When you did that, you invoked the function. You told the JavaScript engine to run it. So now let's talk about what happens when you invoke a function in JavaScript. To do that, let's look at a simple example. So I have a function B that I've created. It does nothing. A function A that calls or invokes function B, and then I'm invoking function A. This is a very simple example, but it helps us to understand what's happening under the hood. Now here comes this fundamental, very important concept. Let's step through what we know is going to happen first if I put this code in a JavaScript file and ran it. First of all, what's going to be created? That's right, a global execution context. The parser will parse the code, and then the compiler, the program that's going to interpret your code, will start up and say, well, I need to create a global execution context. It'll create the variable this. It'll create a global object. If you're in the browser, it will create a window object. And then it will attach these functions to it. It will set up the memory space for them in the creation phase of the execution context, that first phase. So B and A will be in memory. And then the code will be executed line by line. Now, it won't execute anything in those functions because they haven't been invoked. But when it hits A at the bottom, and it says, I'm supposed to invoke or call or run that function A, here's the thing that actually happens. A new execution context is created and placed on what's called the execution stack. And the stack is just what it sounds like. One on top of the other on top of the other. And whichever one is on top is the one that's currently running. So anytime you execute or invoke a function in JavaScript, a new execution context is created and put on the execution stack. So the execution context is created, just like the global one. It will have its own space for variables and functions. It will go through that create phase, and then it will execute line by line the code within the function. However, if I have another function invocation, it's going to stop at that line of code and create another execution context and run that code. Now, in the case of B, there is no code to run, but this is how function invocation happens in JavaScript. Every function creates a new execution context, which runs through the create phase and then executes the code line by line within the function. When B finishes, because it's at the top of the stack, it will get popped off the stack, then A, then back down to global. Notice that this doesn't matter. The order lexically doesn't matter, nor does the rest of the code that happens to be surrounding those function calls. For example, let's suppose we put A above B and we had some other code surrounding these function calls. That doesn't matter, because even though lexically A is above B, remember what's happening. Both of those functions are already in memory during the create phase of the initial global execution context. Those var C, var D that you see down below each of those function calls, let's talk about what's going to happen. First of all, A at the bottom will invoke function A. So that will be the next put on the execution stack, the execution context for the function A. Then that becomes the currently running code, which means that very last line at the bottom, var D, below the A, that's not going to be run yet because JavaScript is synchronous, one line at a time. And what's running is the current code within the current execution context, which is the one at the top of the stack. So when A is at the top of the stack, it will start to run line by line. It hits that line where it invokes B. B creates a new execution context, so that becomes the top of the stack. And so it is running line by line. And it runs its single line of code there. And only when it finishes will we go back to finishing A. Why? Because when the function finishes, the execution context is what's called popped off of the stack. So now what's the current execution context again? A. So it runs the next line of code that hadn't yet been run inside that execution context, meaning that var C line. And then when A is finished, it's popped off the stack, and the next line of code that hasn't yet been run in the global execution context is run, which is that very last var D. See how that works? Every time a function is called, a new execution context is created for that function. The this variable is created for that function. The variables within it are set up during the creation phase. And the code is executed line by line, but every time a function is invoked, even if it's invoking itself, a new execution context is created, put on top of the stack, and then when the function finishes, it's popped off. And whatever's at the top is what's currently running, line by line, synchronously. This concept is very important to have in your mind as your mental model for what's happening as you're invoking functions, because it has to do with the rest of what we're going to discuss. So let's move on talking more about functions, context, and another addition, variable environments. Here's another phrase that's used when talking about JavaScript under the hood. It's a lot more complicated sounding than it really is. Variable environments? Well, big word alert. The variable environment is just talking about where the variables live that you've created and how they relate to each other in memory. So when you think about the variable environment, just think about where is the variable. Let's move on from there. Let's look at a piece of sample code. Again, I have two functions, a function B and a function A. Inside function B, I declare a variable called myVar and don't set it equal to a value. In function A, I set a variable called myVar also and set that equal to 2. And then outside the functions, I also declare a variable called myVar again and set that equal to 1. Then A is called, and inside A, B is called. So what's going to happen? What is the value of myVar at any point in time? To answer that, we need to think again about execution contexts. What's happening as these functions are invoked? So, at first, what happens? the global execution context is created. And so that bottom myvar is put into memory space. In the case of the global execution context, its variable environment is the global object, or a window in a browser. So then the code is executed, and that memory space will get a value of 1 when it hits that myvar equals 1 line. And then it hits the invocation of A. And what happens? A new execution context is created for A. And when it's created, that myvar will be put into that execution context variable environment. See, every execution context has its own variable environment. And its value will then be 2 during the execution phase when that line myvar equals 2 is run. Then it invokes B, and a new execution context with its own variable environment, its own memory space for its variables, is created. And since it's not set equal to a value, myvar will be put into memory with a value of, as we've learned before, undefined. This has to do with something called scope. Just means where are we able to see the variable. Each variable that we are looking at is defined within its own execution context because it's within a function. And every time you call a function, you get your own execution context. So even though the myvar is declared 3 times, they're distinct, they're unique, and they don't touch each other. All right, let's prove that. I've put my code into a JavaScript file, and I've added some console.log so we can see the values. So we set myvar equal to 1, log it, then call function A, which will create a new execution context on the execution stack on top of the global execution context. So this will be the running code. It will create myvar in its own variable environment, log it, and then we start another execution context by invoking a function, and it will put its own variable called myvar into its variable environment, and we'll log that. So what should you expect to see? Well, we're going to expect that we'd see this console.log happen first. It runs A, so we'd see this one second, and then it runs B, so we'd see this one third. So I should see 1, 2, and what will be the value if I haven't set a value? What value does the execution context creation phase set all variables to? That's right, the special value, undefined. So I should see 1, 2, undefined. And so I'm going to go ahead and run this and open up the developer tools, go to the console, and look. 1, 2, undefined. Exactly as we expected. So each of these myvars is sitting in its own execution context. Calling this function didn't affect this myvar. Watch. I'll console.log myvar after calling A. Should that have an impact? The answer is no, because once we finish A, the currently running code is the global execution context, where myvar is 1. So I should see another 1 when I console.log here. Let's say that again. This code is running inside the global execution context. These variables are attached to the variable environment of the global execution context. So when I log this, I see a 1. This calls, and this runs, and that's its own execution context with its own variable environment. The same with B. So when I leave B, A finishes, and when A finishes, I'm back to the global execution context because the B and A execution contexts have been popped off the stack. They're gone. The currently running context is the global execution context, And what was my var in that context? 1. So I'll save this, run it. What should I see? That's right. 1, 2, undefined, 1. See that? 1, because that's inside the global execution context. 2, because that's inside A's execution context. Undefined, because that's inside B's execution context. And then 1 again, because we're back to running inside the global execution context. Got that? Does it make sense? Try this code out for yourself. Mess around with it a bit. See if you understand it. Remember, this is important. And as we move on, if you've got this concept down, it will reveal another concept that's interesting, fundamental, and often causes confusion. But you are going to understand it. Let's move on. This next lecture is on a concept that confuses a lot of people. But now that you're armed with your understanding of the execution stack, execution contexts, and variable environments, the scope chain won't be that difficult for you to understand. Let's take a look at another piece of sample code. Very similar. We have function B, function A, and the myvars again, except in function B, we're not declaring myvar. We're just going to console.log it. So what do you think is going to happen when we get to that line in function B and we console.log myvar? Remember, when B is invoked or executed or run, it creates a new execution context, puts it on the stack, and puts into its variable environment any variables that are declared. But myvar is not declared. So what do you think is going to happen? Let's put the code into our JavaScript file. Again, I'm console.logging myvar inside the B function. And here myvar is 1, here myvar is 2. I'm invoking B, console.log, and at the end I'm invoking A here, so that's where this will all start. So what do you think I'll see in the log? Let's run this. And when I look in the developer tools, in the console, I get a 1. A 1. The value that was sitting here at the global level. Is that what you expected? Some of you might have expected it to be undefined because we didn't define myvar, we didn't declare it inside this function, inside its variable environment. And maybe some of you thought it might be 2 because we called B from function A, and maybe somehow it would know what its value was there. But instead, it's 1, the value at the global level. Let's see why. So remember this. Function B, console.log myvar, was a 1, or what was sitting on the global execution context. Not undefined, not 2. Why? Well, remember, we have our execution stack. At the global level, it was 1. When A is run, we also varred myvar, and that was a value of 2. And then when B was executed, we just console.logged, and we didn't declare anything. And that was just empty. There is no myvar in that execution context variable environment. But when we request a variable, when we do something with a variable, JavaScript does more than just look in the variable environment of the currently executing context. Remember that each execution context has some special things that get created for you, like the variable this. Remember, we also mentioned one other thing that we haven't used yet, the reference to the outer environment. Every execution context has a reference to its outer environment. Now, what is its outer environment? Well, in the case of function B, its outer environment is the global execution context. And that's also the case in function A. Even though A is directly below B in the execution stack as far as what code is going to run, that little outer environment reference that each execution context gets doesn't necessarily have to be the execution context directly below it. Instead, it's something that we've already talked about. What kind of outer environment are we referring to? Remember that big word that we used almost at the beginning of this course? The lexical environment. Wait a minute. Back up. Lexical environment? Didn't that mean that where something is written physically in your code is important? That it determines certain things as far as how the JavaScript engine will decide and interpret where things live and where things will sit in memory and how they'll connect to each other? That's right. So where does function B sit lexically? It lexically sits on top of the global environment. In other words, it's not inside function A. It's sitting right there at the same level as that last line where myvar equals 1. Now, don't get lost about this. We're not changing our minds in that the execution contexts don't matter, don't regard where something is sitting physically in the code. It doesn't. The B could be above the A could be above the B. It doesn't matter. What's going to happen is the order of execution will determine how those are invoked, how those execution contexts are created. However, JavaScript does something special. It cares about the lexical environment when it comes to the outer reference that every execution context gets. And when you ask for a variable while running a line of code inside any particular execution context, if it can't find that variable, it will look at the outer reference and go look for variables there, somewhere down below it in the execution stack. And that outer reference, where that points, is going to depend on where the function sits lexically. So my B function sits lexically, not inside A, but at the global level, right smack dab at the outmost point of the code. And so its outer environment, its outer lexical environment, is global. And so is A's. In JavaScript, when I asked for my var inside that B execution context, it couldn't find it. And so it went down and found it in the global execution context. So again, these execution contexts are created, and it doesn't matter where the code is physically written, where these functions are physically written in regards to when these execution contexts are created. That has to do with when you invoke them. But when you invoke them, when you invoke a function, the JavaScript engine creates an outer reference for that execution context, and it looks at where the code was physically sitting. The syntax parser already knows, because it went through line by line your code, and it knows where that function was written, and it then creates the appropriate outer reference based on where your function was physically written in the JavaScript file. Now, this entire act of searching, this chain of references to outer environments, because this execution context stack could get really tall, and maybe my var is a ways down the stack. It has to search one and then look for another outer environment and search again until it gets all the way to the bottom where the global is, where there is no outer environment, to find my var. So if I had several more functions calling each other, it would keep on moving down until it hit global, if those functions were defined inside each other, down those outer environment references until it finds it or doesn't. That whole chain is called the scope chain. Remember, scope means where can I access a variable? And the chain is those links of outer environment references, lexical. That is where it was physically written in your code. So when we said inside function B, console.log myvar, it looked for myvar, couldn't find it, and went down the scope chain. Now, it's going to go down the execution stack, but it jumps because it's not necessarily right below it. The outer environment, in this case, lexically, was global. All right, let's show how we can change this by changing the lexical environment of the function. All right, so let's take a look at function B again. Where is it lexically? Well, it's lexically sitting in the global environment. Remember that this is where it sits. It's actually attached to the global object. It's declared lexically, physically, at the same spot that myvar is. It's not inside a function, it's just there on the JavaScript file. So, the JavaScript engine, when it generates the execution context, when B is called, it creates that execution context and creates an outer environment along with the this variable and other things. It creates an outer environment reference to the lexical environment. That is to say, hey, the JavaScript engine saw that the function is sitting physically here, or it could also be sitting physically here, doesn't matter. It's sitting physically, though, not inside any other functions, so its outer reference is the global execution context variable environment. So when it looks for myvar, it can't find it in here, so it goes down the scope chain, skips over that A execution context because it's not lexically in there, and finds it here. So when I run this code, I get a 1. But if I change the lexical environment and put function B inside function A few things happen. I've changed the lexical environment of B, meaning that I've changed where it physically sits in the code so that it's inside a function. And so its environment is different. Immediately, that means I can no longer just call B out here at the global level, because what will happen is the global execution environment will look for the function B, but that was never added to its variable environment because it's inside A. So the JavaScript engine, when it created the global execution context, it found function A and added it, but it didn't go look inside function A or anything like that. It just went to the end of function A and kept going. So there is no B in the global execution context. So I'm going to get an uncaught reference. B is not defined. See that? Because that first creation phase didn't find function B in the global execution context was created, only function A, because that's where it's sitting lexically. Function A is visible lexically, but not B. However, when I call A, did you notice what the value was? I called A. A's execution environment is created, its execution context, and when I call B, what's my var? 2. Do you see what just happened? All right, so what just happened? Well, the same execution contexts were created. A global, and then A was called, and then B was called. However, because B was sitting physically inside the A function, the JavaScript engine said, well, its outer reference will then be A, because that's where it's physically sitting. And A's would then still be the global. And so when we asked for myvar this time, when it went down the scope chain because it couldn't find it in B, instead of going to global, it went to A. Found myvar, it said, hey, you asked for myvar, and when I went to the outer lexical environment, I found myvar, and so it's 2. Make sense? The outer lexical environment of B is A this time because B was physically sitting in the physical code that we typed. It was physically sitting inside function A. So where something sits physically, thinking lexically, is a really easy way to figure out how something will be found along the scope chain. In other words, if I don't declare a variable inside a function, where will I go find it? So function B is sitting inside A. So if I don't declare it inside B, it will go look for it first inside A. If it can't find it inside A, A's outer reference is to global, and so it'll look for it there. So notice I just got rid of that. It's back to 1. See, it went up or down, depending on how you want to think about it, the chain, the scope chain. So I look for my var in the B execution context. Can't find it. The outer reference is A. Can't find it. The outer reference of A is global. Hey, there it is. See how that works? Now, another way to think about this, if you don't want to think lexically, is who created me? The outer reference is to the execution context in which the function was created. So in this case, function B isn't created until A's execution context is created, right? Because the global is just going to add my var and A. Then when A is run, it's going to go through its create phase and say, I need to create B. And since B was created during the creation phase of A's execution context, that's its outer environment. If I moved B back out, then now when is B created? B is created when the global execution context is created. And so that's its outer reference. It's a different way of thinking about it. It still works. But the fastest way to think about it, in my opinion, is thinking about it lexically. That way you can just look at your code and know, oh, if I have code that looks like this, this is going to be a 2 because of where it sits physically, lexically. Make sense? All right, so again, if I just remove all of this, it will go all the way up the scope chain, and I still get a 1. All right, so we've learned that where a function sits determines its outer environment reference. But as it's being executed, those execution contexts are stacking up, and it's running synchronously. We've learned quite a bit, and we're understanding the scope chain. This concept can be confusing for people. It can be a little weird. But if you understand what's happening under the hood of JavaScript, you'll be able to determine what's really happening to your code. And when you have a problem, when a variable is an unexpected value, you'll be able to debug it and say, I know why it is what it is, because I know how this really works. All right, let's move on. So we've talked about execution contexts, execution environments, variable environments, lexical environments. And all of these things ultimately are defining what's called scope, especially when we talked about the scope chain, that outer reference that any running function has. So, big word alert. Scope is where a variable is available in your code. And sometimes it has to do if it's really even the same variable or a new copy. Like if you call the same function twice, it each gets its own execution context, and though it looks like the same variable, it's actually 2 different variables in memory. But in the end, we're understanding that all these things we've been talking about have helped us to understand something that a lot of developers find confusing. But because of diving under the hood of JavaScript and seeing how it deals with variables and functions, I hope you see how this helps us understand scope on a deeper level and in a way that it doesn't seem so odd or so strange or so difficult to anticipate. This again goes to my philosophy about learning code. Some people say that they learn code better by example. And again, examples are important, and we've looked at some already. But understanding how things really work makes you a better developer. It makes you a better coder. I stand by that philosophy because I've seen it work. I've seen it in production environments with large teams of coders. Those that learn how things really work under the hood solve problems better and are better coders overall in the end. All right, so we've talked about scope. I just want to mention one more thing. The next version of JavaScript, which is called ECMAScript 6, or sometimes ECMAScript 2015, or just ES6, is introducing a new way of declaring variables. It's called let. This is used, or can be used, instead of var. Although it's not replacing it, var will still be around. But let allows the JavaScript engine to use what's called block scoping. So you can declare a variable just like you would with var. And during the execution phase where it's created, that variable is still placed into memory and set to undefined. However, you're not allowed to use it until the line of code is run during the execution phase that actually declares the variable. So if you tried to use C in this example before the let C equal true, you'd get an error. Now it's still in memory, but the engine just won't allow it. The other important thing is that it's declared inside a block. Blocks are in general defined by curly braces, so inside an if statement or a for loop or something like that. When that variable is declared inside that block, it's only available inside that block at that period of time for the running code. This is true even for for loops. So if you have a loop and are running the same code over and over, but you have a let statement, you'll actually get a different variable in memory each time the loop is running. So this allows for what's called block scoping, as we mentioned, which others who are used to other programming languages may be familiar with. But again, you can use both let and var in ES6, and it's good to know and understand how both work. We'll talk about this more later in the course, but I just wanted to mention it now, that there are more options available in the next version of JavaScript for how you scope a variable. Before we finish up this section, let's go back to a question that many of you were likely asking. We've been talking about all this synchronicity in JavaScript, how things are executed synchronously. But what about asynchronous callbacks? Many of you may have used these or perhaps have heard of them. Well, first of all, big word alert. What do we mean by asynchronous? Asynchronous simply means more than one at a time. So we may be dealing with code that's executing and that starts off some other code to execute, and that may start other code executing, and all of those pieces of code are actually executing within the engine at the same time. But JavaScript, as we've said, is synchronous. It doesn't execute asynchronously. It executes code a line at a time. Yet there are things like click events, or you can go off and get data in JavaScript and get it back, where you have callback functions that run when that event is complete, when that action is complete. So since JavaScript is synchronous, how does it handle, or how is this handling those asynchronous events? Well, first of all, we need to think about the JavaScript engine itself. When we're talking about running JavaScript and the JavaScript engine itself, we understand that it doesn't exist by itself inside, for example, an internet browser. There are other elements, there are other engines and running pieces of code that are happening outside the JavaScript engine that runs JavaScript when you load it into the browser. So there's things like the rendering engine that actually renders or prints or paints to the screen, whatever the web page is that you're looking at. Or there's elements of the browser that have to do with going out and getting HTTP requests, responses. So going out, for example, and getting data. And the JavaScript engine has hooks where it can talk to the rendering engine and change what the web page looks like, or go out and request data. But all that is running, while it may be running asynchronously, meaning that the rendering engine and the JavaScript engine and the request are running asynchronously inside the browser, what's happening inside just the JavaScript engine is synchronous. So when we asynchronously go out and make a request, or we say, let's run a function when someone clicks on a button, what happens? Because that is being handled asynchronously. Other parts of the browser are running and looking at that code while the JavaScript code is still running. All right, so let's take a look. We've already learned about the execution stack, that we have these execution contexts that are being created, and as functions are being called, they're being run, stacked on top of each other, and as they finish, they leave the stack. There's another, however, list that sits inside the JavaScript engine called the event queue. And this is full of events, notifications of events that might be happening. So when the browser, somewhere outside the JavaScript engine, has an event that inside the JavaScript engine we want to be notified of, it gets placed on the queue. And whether or not we actually have a function that needs to respond to it, well, we can listen for that event and have that function handle that event. But either way, the event gets placed on the queue. So a click event, for example, if someone clicks on the screen. Now, what happens if I have a function that's supposed to respond to that click event? Or maybe another event happens while code is running, like I went out and got data and that code went out to the browser went and got the data while my code kept running, and now it's finished. Well, what happens is that event queue gets looked at by JavaScript when the execution stack is empty. So let's say my function B finishes, and now it's going to run function A, finish whatever's going on there. And when that finishes, it keeps going and finishes whatever execution is at the global level. And when the stack is empty, then JavaScript periodically looks at the event queue. It waits for something to be there. And if something is there, it looks to see if a particular function should be run when that event was triggered. So it sees a click event, it processes that click event and knows, hey, there's a function that needs to be run for that event. So it creates the execution context for whatever function when that event happened. And so that event is processed, and the next item in the queue moves up, and so on and so forth. But again, the event queue won't be processed until the execution stack is empty, until JavaScript is finished running all of that other code line by line. So it isn't really asynchronous. What's happening is the browser asynchronously is putting things into the event queue, but the code that is running is still running line by line, and then when this is empty, when the execution context are all gone, all finished, then it processes the events. It waits for them and sees an event, and if an event causes a function to be created and executed, and there it is. It will appear on the execution stack and run like normal. All right, let's see some code so we can see what this looks like. So I have some code here to show what happens as far as how JavaScript handles asynchronous callbacks. I have a function here that essentially simulates a function or an action that takes a long time. So this while loop is just going to wait 3 seconds. It'll force this function to take 3 seconds to finish running. And then when it's finished, it'll console.log it. I also have a function that's my click handler. So I'm going to listen for a browser event. I'm going to listen for a click event to appear in that event queue. And I'm going to run the click handler function. That's what this line does. I'm listening for click, and I'll run this click handler function when the JavaScript engine decides to go look at and process the event queue. So then I run this function, the long one, and I'm going to click around on the page while this 3-second function is running to see what happens, and then I'm going to console.log that I'm completely finished. So I should see all three of these console.logs. But the question is, if I run the page and click while this function is running, the one that takes 3 seconds, in what order will these three console.logs appear? So I'm going to run this in my browser, and you'll notice it takes 3 seconds for the page to finish loading. That's that long-running function. And because I didn't click anything, notice that I have finished my function and then finished the execution, and that's based on how we understand it. This function, when invoked here, was placed on the execution stack, and execution context was created. It's running. When it finished, it outputted that. Then this left the execution stack, and the global code continued running, and that's what we see in that order. Now, if I refresh this page and click while the long-running function is running, while it's executing, what should happen? Well, the browser is going to place that click event on the event queue, but when is JavaScript going to look at that event queue and process it? I'll refresh, click, and there we go. Are you surprised? Notice that the function completed and the global code completed before it went off and created an execution context for that click handler function. Why? Because the JavaScript engine won't look at the event queue until the stack is empty. So that means long-running functions can actually interrupt events being handled. But this is how JavaScript synchronously is dealing with the fact that asynchronous events are happening, that elsewhere, simultaneously in the browser in this example, things are happening that then complete, that JavaScript needs to know about. So all it does, it just keeps running its normal code, and when that's all done, it will then go and look at the event queue. And if it's already done, then it will just continue to watch that event queue in the loop, the event loop. That's what that's called, that continuous check. And then when it sees something, if there's supposed to be a function, if there's a handler, if there's a listener that's supposed to run when that event appears in the event queue, it will run it. So that's how JavaScript, though synchronous, deals with asynchronous events. Any events that happen outside of the engine get placed into that queue, and if the execution stack is empty, if JavaScript isn't working on anything else currently, it'll process those events, and it will process the events in the order they happened. So if a click event happens and then an HTTP event, it will process the click first and then run that function, complete that function, then look at the queue, start looking at the queue again. All right, so again, asynchronous callbacks are possible in JavaScript, but the asynchronous part is really about what's happening outside the JavaScript engine. And JavaScript, via this event loop, via this list of events that are happening, when it's ready, will look at events and process them. But it does so synchronously. It's time for another conceptual aside. Types and JavaScript. JavaScript is special, different than what you might be used to if you're coming from another programming language when it comes to the types of data that variables hold and how JavaScript deals with them. So before we start with that, big word alert. We're going to discuss a term that describes how JavaScript deals with types. It's called dynamic typing. That means that you don't tell the JavaScript engine what type of data a variable holds. You don't put that into the code that you're writing. Instead, the engine figures it out while your code is running, while it's executing. And so a single variable can, at different times during the execution of your code, hold different types of values because it's all figured out during execution. All right, for example, when you're dealing with other programming languages like Java or C#, they use something called static typing. That means you tell the engine ahead of time, the compiler ahead of time, what kind of data you intend to hold inside a variable. So you might have a keyword like bool to say that this variable should hold a Boolean value, either true or false. And then if you try to put a value that's other than a Boolean into that variable, you get an error. But JavaScript isn't like that. JavaScript is dynamically typed, meaning that there is no keyword to tell the engine what kind of data you intend to put inside the variable. We just say var, for example, and then while the code is running, the JavaScript engine will determine what type you're giving that variable. And you could change it. I could put those 3 lines in order, make it true, and at that moment the engine will say, you must mean this to be a Boolean type, and I could give it a string, yep, and it'll say, yep, you must have intended a string type, and I could give it a 1, not inside quotes, and it will say, this is supposed to be a numeric type. So JavaScript is dynamically typed. It figures it out on the fly. This turns out to be quite powerful and can also cause you some problems if you don't understand how JavaScript is going to make decisions as a result of dynamic typing. Before we can dive further into how dynamic typing works and both its advantages and its disadvantages, we need to talk a bit about the types that exist in JavaScript, the types of data that you can store in a variable. Again, you don't say this directly through the variable declaration, but there are 6 primitive types in JavaScript. All right, now 1 second. Big word alert. What do we mean by primitive type? A primitive type is a type of data that represents a single value. In other words, something that isn't an object. Because remember, an object is a collection of name-value pairs. A primitive type, on the other hand, is just a single value. And again, there are 6 types in JavaScript. So let's talk about each of the primitive types. First, we have undefined. We've already talked about this at some length. Undefined represents a lack of existence. And it's what the JavaScript engine sets variables to initially, and it'll stay undefined unless you set the variable to have a value. So you really shouldn't use this as far as setting a value. You shouldn't say a variable equals undefined. Just let that be the thing that means the code has never set the value. But you can certainly test for it. The second primitive type is null. Null also represents lack of existence. This one is better for you to use when you want to say that something doesn't exist, that the variable has no value. So leave undefined for the engine, and you can use null, the keyword null lowercase, for your variables when you want to set them equal to nothing. Next is Boolean. This is familiar to most programmers. This is either true or false, just one of 2 values. And in JavaScript, it's literally the word true or the word false lowercase. Next comes number, another primitive or simple type. In JavaScript, actually, there's only one numeric type, and it's called number. It's a floating point number, meaning that essentially there's always some decimals attached to it. Unlike other programming languages, others might have integer and decimal and other specific numeric types. JavaScript only has one. And while you can fake it as far as integers and other types of mathematical numbers are concerned, there really is under the hood only one type called number, and it's a floating point number, and it can make math a little weird. Another familiar one is string. This is another base primitive type in JavaScript. It's a sequence of characters, and both single quotes and double quotes can be used to specify that we're dealing with a string. In some programming languages, a string is more complex and treated as a sequence of characters, but in JavaScript, a string is considered a primitive type. And finally, the 6th one. This one's new, and it's called symbol. It's used in ES6, or ECMAScript 6, which is the next version of JavaScript. It's being constructed and not fully supported by all browsers. So we're not going to talk about this here, but as time goes on in this course, I'll occasionally post bonus lectures, especially throughout this year as more and more is talked about with ECMAScript 6. But for our purposes, we're just going to ignore the symbol as a primitive type in this course. However, it's just good that you know that it's coming. So that's it. The 6 primitive types in JavaScript: undefined, null, Boolean, number, string, and symbol. Are you bored yet? I know. Well, we just needed to establish this because understanding the primitive types and the fact that we're dealing with dynamic typing, that is, that the engine is figuring out what type a variable is on the fly, is key to understanding certain aspects of JavaScript and really weird, funky problems and bugs that you can come up with that can be difficult to debug or understand. So we needed to first establish types, and we'll focus on primitive types here. And then we're going to move on to another topic and then combine these two topics to fully understand some things that people normally have problems with in JavaScript. It's time for another conceptual aside. We've already talked about types. Now it's time to talk in depth about another concept which will help us to debug and understand some other kinds of problems people have in JavaScript because of its dynamic typing. Let's talk about operators. If you don't come from a computer science background, what we're about to discuss may surprise you. Well, either way. Big word alert. Operators. What do we mean? An operator is actually a special function that is syntactically, or that is written differently than regular functions are written in your code. Generally, operators take 2 parameters and return 1 result. Let's look at an example. I'm back to my index.html and my app.js file, and I'm going to increase my font size here inside brackets just because what we're about to discuss involves operators which are generally 1 or 2 characters long. So I want to make sure that this is seen clearly in the video. Alright, so let's say that I declare a variable a, and I'm going to set it equal to 3 plus 4, and then console.log a. Alright, so let me run this, and I bet you can guess what I'm going to see on the screen. That's right, 7. 3 plus 4 is 7. Obvious. But here's a question you may not have asked yourself. How did the JavaScript engine do that? How did it know that this was my intent to add 3 and 4? Well, the syntax parser and the rest of the aspects of the engine looked at this code, saw the plus sign, and added these 2 numbers. This plus sign is an operator. It's the addition operator. And it's actually a function. It'd be kind of like this. It would be as if I declared a function, and instead of giving it the name add, and then maybe 2 numbers, I instead simply gave it the name plus. Gave it 2 numbers, and then returned, and then somewhere in there add the 2 numbers. That was essentially what happened when JavaScript saw this line of code. The difference is that instead of calling the function as you normally would, if this was a function name, I would then put parentheses and pass 3 and 4 to it, and that would have been a normal function call. But that would be a really annoying way to have to type your functions for common operators like plus. So instead, the JavaScript engine provides, along with many programming languages, the option or the ability to write in what's called infix notation. Infix means that the function name the operator sits between the two parameters. So instead of plus 3, 4, calling the function this way, imagine that instead we remove the parens and the comma. That's called prefix notation. I could put the plus sign at the end. That would be called postfix notation. A lot of old school accounting calculators work this way, where you put the operator at the end. But for our purposes in JavaScript, this is infix notation. It's very human readable. But this is essentially a function call passing two parameters, and this function returns a value. The value that it returns, in the case of the addition operator, is these two parameters added together. So plus is an operator. There are other operators, common ones that you've used most likely, like if I swap this and do minus, and console.log this value, what am I going to get? Obviously a 1, because this is an operator, the minus sign. Or if I asked a question, 4 greater than 3, this is a function, a special one, an operator, the greater than function, or the greater than operator. This is different because it accepts two numbers and returns a Boolean. Remember those primitives that we talked about. So this will be true if the left parameter is greater than the right parameter, and it will be false otherwise. So if I refresh this, then yes, 4 is greater than 3. So this function accepted two numbers and returned a Boolean. So this is the concept to keep in mind, that when we type these operators, plus, minus, less than, greater than, and a bunch of others that we'll talk about in just a moment, that these are actually special types of functions, that these parameters are being passed to those functions and a value is being returned. And inside those functions, there is pre-written code essentially for you that the JavaScript language the engine provides to do or run or invoke these functions. And what's happening inside those functions is important to understand, especially when dealing with a dynamically typed language like JavaScript, where you don't necessarily know ahead of time what type the variable is. The JavaScript engine will behave in special ways because of that. But for now here, let's just keep in mind that operators are functions. Operator precedence and associativity. We'll extend our discussion of operators to discuss these two very important terms. But precedence and associativity, those again are some of those big words that describe things that are a lot simpler than what they sound like. So, big word alert. First of all, operator precedence. Operator precedence just means which operator function gets called first when there's more than one on the same line of executable code. And functions then are called in order of precedence. The higher precedence wins. So if I have more than one operator, the JavaScript engine will call or invoke the operator with the higher precedence first, or the highest, and then down the line from there. We'll see an example in just a bit. But before we do that, we need to add on one more concept that goes along with this. We mentioned it, operator associativity. Yeah, another big word alert. It's not as complex as it sounds either. Associativity. That's what order an operator gets called in. So again, we're talking about which operator function in what order. In this case, either left to right associativity, or called left associativity, or right to left, which is called right associativity. And this means when the operator functions have the same precedence. So if I have a bunch of operators on a line of code, the precedence tells me which ones gets called first, but if I have some of them, they all have the same precedence, then what do I do? Well, depending on the associativity of that operator, we're either going to call the functions left to right, or we'll call the functions right to left. All right, let's look at some examples. All right, so let's say I'm going to have another calculation here, and I'm going to say 3 plus 4 times 5, and output this. Now, what do you think the answer is going to be? Well, if you remember from mathematics class, there is an order, a precedence in mathematics in general to these operators, and JavaScript does the same thing. Because there's one of two options. These are two function calls. And remember, JavaScript is synchronous, so it's not going to try to do this simultaneously. It's going to call one and then call the other. But which one gets called first? Well, first of all, we'll start with operator precedence. And in order to answer this question, we need to know what the operator precedence is in JavaScript. There's a terrific link, which I'll provide in the next lecture, on the Mozilla Developer Network, or MDN. That's developer.mozilla.org, called operator precedence for JavaScript. And it actually has a table of operator precedence. What I've done is taken this table and provided you a PDF, which you can download. It's attached to this lecture for download. And we'll use this PDF to discuss this. So, again, remember that what's happening is these are two functions. Operators are special types of functions. And so the one with the higher precedence gets called first. So the bigger the number on this table, that means the one with the biggest number will get called first, and the second biggest number will get called second, etc., until all of the operators are done. So if I go down to this section of the PDF, to explain what these little symbols here mean, this is the operator. There are a large number of operators in JavaScript. You can see them all in this PDF. And these 3 dots just mean other code around it. So in this case, multiplication is a asterisk, division, addition, subtraction, remainder, and then there's just code around it. So a left parameter and a right parameters. So these are the parameters being passed to that function. So in my sample, I have multiplication and addition. Notice that multiplication has a precedence of 14, and addition has a precedence of 13. And with operator precedence, the higher one gets called first. So multiplication is higher, or has a higher precedence than addition. That means that what's going to happen is this will get called first. And remember that this returns a value. So what's really happening is 4 times 5 is run. This operator function is invoked and returns 20, 4 times 5. And then, because this has the lower precedence, this is called using that returned value as the second parameter. And so that's called, and it's 23. Equals is also an operator. And essentially what we're doing is setting a equal to 23. If the precedence was different, then it would do 3 plus 4. If that was first, that would be 7. And 7 times 5 is 35. So we'd end up with a as 35. So the precedence makes a big difference in the value we get. 23 if times or multiplication has the higher precedence, and 35 if addition has the higher precedence. But we've already seen that multiplication has the higher precedence in JavaScript. So when I run this, I get 23. I get 23 because this function is called first, and I get a 20. And then this function is called, and I get a 23. Make sense? That's a very important concept to understand some of the strange bugs, or things that look weird anyway, that can happen to people when writing JavaScript code. Now, what if more than one operator, and I could have many in a row, has the same associativity? Let's go back to our table. Notice that in some cases, for example, multiplication, division, and remainder, all have the same associativity. Or I could have the same operator on one line of code. Well, let's take a moment and look at this. I'm going to change what I'm doing here. I'm going to say var a is 2 and var b is 3 and c is 4. So I now have 3 variables with 3 different values. And then I'm going to run a statement. A equals B equals C. And then I'll console.log all of these 3 variables. All right, let's look at this. I have 3 of 3 different values, and then I'm setting A equal to B equal to C. So in the end, they should all be equal, but the question is, what value will they all have when I console.log this? Will they all be 2? Will they all be 3? Or will they all be 4? What do you think? Take a look at the results when I refresh. They're all equal to 4. Why? Because of associativity. That's this column here in the table. Associativity is either left associativity, meaning the furthest one to the left, the furthest operator to the left will be called first, or right to left, or right associativity, meaning the operator furthest to the right will be called first. And that's really it. Pretty simple. All right, so the operator I'm using is the equals operator, or the assignment of equal. That's one of the assignment operators. Notice that its associativity is right to left. So the equals operator is right associative. It has right to left associativity, meaning that when I have it on a single line, since it's the same precedence, it then looks at the associativity to decide which one should be called first. So it goes to the furthest one to the right because it's right to left associativity. So it'll call this one first. If it was left to right associativity, it would call this one first because that's farthest to the left. But no, it's right to left, so this is furthest to the right on this line, and so it calls this. So it will set B equal to C, and what is C? 4. Now here's the interesting thing. We said that operators generally take 2 parameters and return a value. So the plus operator returned the value of the addition of the 2 parameters. But what does equals return? All right, let's go back to our console window. I'm going to set B equal to C, so it will run this operator, and the console window will show me the return value. See, the method or the function called was invoked. It did the work of setting the value in memory of B equal to the value in memory of C, and then returned the value of the parameter on the right, the parameter that we're setting equal to. So it gave me back a 4. So this statement actually returns a value. It's a function that returns a value. So that means I can call it in order. So since this is right to left associativity, this is furthest to the left, this is furthest to the right, this is called first, it sets B equal to 4 because C is 4 and returns a 4. And then this will be called. So A will simply be set equal to 4 because that's what this returned. A is 4. So when this is done calling, first this operator, then this operator against the returned value, A, B, and C are all equal to 4. Make sense? That's operator precedence and associativity. Precedence helps us determine which functions run first, and so does associativity. Associativity comes into play when two or more operators have the same precedence. So if an operator has precedence 14 and another one 13, 14 gets run first. But if they both have 13 or some other value, then it's either left to right or right to left. And we can see this in action if we go back to our original example where we said A was equal to 3 plus 4 times 5, like that, something like that. So this ended up being 23 because precedence said 4 times 5, 20 plus 3. But notice in our operator precedence table, what's at the very top of the precedence table is called grouping. And that means I can put something inside parentheses. That's our special operator in this case. And unlike some of these other operators, it simply takes whatever's inside of it and says, run this first. So whatever's in the parens always gets executed first. Those functions get called first. So if I put 3 plus 4 in parentheses, now what's going to happen? Well, JavaScript looks and sees that parentheses have a level 19 highest possible precedence, and so runs this function that's inside of it first, the plus. And then the 3 plus 4 is 7, and we'll then multiply that times 5. So if I run this, I get 35. Without the parentheses, the precedence rule says, well, this has a higher precedence than plus, and so I get 23. With the parens, it changes the order that the functions are executed, and that's all it's really doing. So, operator precedence and associativity. You got that? This is important again because JavaScript is dynamically typed, and we'll see that very soon. It's time for another conceptual aside. This is another important concept that deals with some of the weirder, surprising things that can happen sometimes in JavaScript because it's a dynamically typed language, but also can be very powerful. This concept is coercion. All right, you know what that means. Big word alert. Coercion. Converting a value from one type to another. That's all it really means. You might have a number and you coerce it or attempt to convert it to a string. Or you have a string and you coerce it or attempt to convert it to a number. And so on and so forth. This happens quite a bit in JavaScript because it's dynamically typed. Let's look at an example. So I've already seen that I have an operator and it takes two parameters and that this is a function that returns a value. So A is set equal to 3 because 1 plus 2 is 3. Very clear. Now you may also know that the plus operator is used to do something else. If I pass two numbers to the plus operator, then I get addition. But if I pass two strings like hello and world, then instead of trying to add it as numbers, it concatenates the string. It puts them together. Now, here's the question. What if I pass the operator two different types? If I give this function a number and a string, what do you think is going to happen? What will be my value? Well, I refresh, and I get what looks like 12. Oh, wait a minute. Did the math just go haywire? No. What I got was as if these were two strings, and it simply put them together, 1 and then 2. So what just happened? What happened was that this value, the first parameter, was coerced by the JavaScript engine into a string. in memory, the string 1 and the number 1 look nothing alike. Now, they look awful similar when you're typing on the screen, but actually in the computer memory, the number 1 and the string 1 don't look anything alike. But the JavaScript engine was smart enough to say, well, I know the people that coded the JavaScript engine coded this guess, this best guess into the engine, said when you call the plus operator, this function, and you give me a number and a string, then I'm going to make a choice to try to coerce that number. I'm going to try to figure out what it would be if it was a string. And the JavaScript engine successfully coerced that one. It didn't literally type those in, those characters, but under the hood it coerced that from the number 1 to the string representation of the number 1, and then finished running that function. Notice that I didn't ask JavaScript to coerce this value. I didn't type something here special that said some kind of convert this to a string value or something like that. I simply called the function with these two parameters, and when the function ran, it chose to coerce my value instead of giving me an error, which is what some other programming languages would do. And this has a lot to do with the fact that JavaScript is dynamically typed, so it tends to try to convert things to the value that you want, because you're not explicitly telling it what values types should be. This was just happening under the hood of the JavaScript engine. And understanding that coercion is happening is very important, because you can avoid some important bugs and debug things when things look a little strange. For example, if someone had accidentally typed this, you would understand that 1 plus 2 is 12 because of coercion, because this is a string and this is a number, and it's being coerced. Sometimes these things can be hard to pick up on. For example, if I had just said var a equals 1 and b equals 2, and then I outputted a plus b, I still get 12, because b is a string and a is a number, and it coerced a. But if there was a whole bunch of code in between these two lines, and this b was set somewhere else in the code, you could be really confused by the fact that that's returning 12. But we understand coercion, so we can track down what's really happening. And we also understand that operators are just functions, so they're running code. And coercion is part of that process of calling that function. So we understand that JavaScript is doing its best to understand what something should be, that it's dynamically typed, and that coercion is a fundamental part of the JavaScript language as a result. All right, let's move on. It's time to talk about comparison operators in JavaScript. And here's where we'll see that what we've been discussing, all these things that may have felt not very necessary till now, regarding operators and precedence and associativity and coercion, where they all come together to explain some behaviors in JavaScript that many find confusing. So again, I have a blank app.js file, and we're going to try some things. And I encourage you to try these things yourself in your app.js file or in the console, in the dev tools of your browser. Mess around. As we discuss, you want to be able to understand and be familiar with some of the quirks that we're going to see. All right, so for example, I'm going to console.log a statement that should look pretty obvious. 1 is less than 2 is less than 3. So, as a human, what would you expect the result to be? Again, these are less than operator, so it's going to return a Boolean, either this is true or false. If I just read this, 1 is less than 2 is less than 3, I would expect that to be true. because it is true. 1 is less than 2, and 2 is less than 3. So if I run this, it appears that the browser agrees, that the JavaScript engine inside the browser ran that statement and agrees with that, because it said true. All right, let's change this to 3 is less than 2 is less than 1. Well, that should be false, right? 3 is not less than 2, 2 is not less than 1. I run that, and that's also true. So why is this returning true? And for that matter, why did 1 is less than 2 is less than 3 return true? Well, we can start to answer this by using the knowledge we've gained about operator precedence and associativity. These are two less than operators, so they have the same precedence. So what determines which one gets run first? Well, associativity. And if I scroll down and find the less than operator, I see that it's left to right associativity. See that? That means the one furthest to the left will get run first. So what does 3 less than 2 return? Well, we know that. If I clear this and go 3 less than 2, it returns false. So that means what's really happening is that this is being run. The second operator function, when it's invoked, is getting past the parameters 1 and false. And what does an operator in JavaScript try to do when I give it a value that's a type it doesn't expect? This wants two numbers, and I'm giving it a number and a Boolean. Well, it's going to try to coerce or convert this Boolean to a number. Well, what does false become when I try to convert it to a number? Well, we can actually see this. If I open up the console, I'll clear this again. I can use a built-in function. I recommend that you don't use this, but it's very useful to see what things will coerce to. However, we'll talk about this later in the course, about using these and not using these built-in functions. But just to show what something coerces to, I'm going to use the number function, where I can give it a value, any value, and it will show me what this will coerce to, because it will try to convert it to a number. So if I, for example, try to coerce the string 3, I get a 3 back, as we've talked about. All right, so I'm going to try to coerce a Boolean false to a number. What does it become? A 0. Well, that's interesting. Actually, true and false both can coerce. False becomes a 0, and true becomes a 1. So what does that mean is happening? Well, over here, when this less than operator is invoked, and it coerces false, it's actually running this statement. Is 0 less than 1? Because it converted the Boolean to a different type, to a number, and that became a 0. So is 0 less than 1? Yes. So this becomes true. So if I look at the order again, 3 is less than 2 is false, left to right associativity, that was called first. False is less than 1, false becomes coerced or converted to 0. 0 is less than 1, that's true. So this sequence of function calls, 3 is less than 2 is less than 1, although it looks from a human perspective like it should obviously be false, from the JavaScript engine's perspective, which parses and executes this code, it makes perfect sense that this result would be true, because of the order of execution of these function operators and the coercion of the resulting values. But we can see how not understanding these things could lead one to feel that JavaScript is behaving in a weird or strange manner. Let's go back to 1 is less than 2 is less than 3. Now that we have a grasp of what's really happening, we can see that even though this is returning true, it's not because it's doing what we're doing as humans, looking at that and saying, yes, obviously that's true. What's actually happening is it's running this function first because of left associativity of the less than operator. 1 is less than 2 is true. True less than 3, this function operator is invoked. True is coerced. Remember what that was. True becomes a 1, and 1 is less than 3 is true. And so we get true. So we see that coercion can cause some, from a human perspective, surprising results, but from the computer's perspective, from the JavaScript engine, this makes total sense. Now, that is to say that not every case is going to coerce in a way that is expected. For example, I can coerce false or true to a number. I can coerce a string to a number if that string looks like a number. But if I try to coerce, for example, undefined, I get this special thing, NaN, which literally means not a number. This isn't exactly a primitive type, but you can basically treat it as such. Not a number means I have this thing that I tried to convert to a number, and it just isn't a number. There's no way to convert it to a number. So undefined couldn't convert to a number. Or null. Oh, well, wait a minute. Null, JavaScript decides, is a 0. So you see what's happening? It isn't always obvious what a particular type is going to coerce to. The JavaScript engine decides. This can cause a lot of strange bugs and odd problems if you don't understand, again, what's going on. You can believe that undefined and null are going to behave the same way, but they won't. So while coercion is very powerful, it can also be dangerous. So wouldn't it be nice if we had a way to not coerce under a certain very common circumstance? That is, checking if two things are equal. Well, we do. Let's pull up our JavaScript operator precedence table again. All right, I'm going to scroll down to find something very common in programming languages, equality. It's a double equals, meaning are two things equal? We often put this in if statements, if something equals something else. So if I open up my browser and clear this, it might be something like 3 equals 3. This is an operator, and it returns true or false. True. If I pass it the string 3 and 3, very much like those operators that we've seen, the double equals operator will coerce the types. It expects two of the same type, and if they're not, it will make a choice. True. It coerced one type and then checked equality. But again, we saw that this can be a little strange. This can cause some strange side effects. For example, if I clear this, we know that false, when converted to a number, when coerced, becomes a 0. So that means false double equals 0 is true. Strange, right? That means var a equals false. I have a variable that's a Boolean. And if I check if a is 0, it says yes, a is 0 because of coercion. This can cause those kind of strange problems that are hard to debug. Or I already said false equals 0. That's true. How about null equals 0? Remember, null also coerces to 0 as a number. Oh, but that's false. So there are special cases like undefined and null that don't do what you would expect. False equals 0. Yes, but null, although it coerces to 0 under other circumstances, like null is less than 1, it doesn't coerce to 0 for comparison. This causes all sorts of confusion and problems and is actually considered a negative part of the language, in that comparison operators, especially double equals, causes strange errors because of unexpected ways in which it behaves. I'll show you another one. Double equals using an empty string and 0. That's true. So if I have empty string and false, that's also true. You see the problem? It makes some sense because it's attempting to convert these values to the same type, but it can make your code very difficult to anticipate as far as what's going to happen. So how do we solve this? Well, we'll go back to our operator precedence table, and we saw the double equals, which is equality. But there's also a triple equals, which is called strict equality. And the same, there's regular inequality, not equal, using the exclamation mark, and there's strict inequality, not equal, using an exclamation mark and a double equals. So when people see these triple equals for the first time, especially if coming from another programming language, the first response is, what in the world is that? That is going to save your life. Strict inequality, the triple equals, compares two things. It's a standard operator, but doesn't try to coerce the values. If the two values are not the same type, it just says no, they're not equal, and returns false. So if I clear this, 3 triple equals 3 is true, because those are both numeric. 3 triple equals 3, the strings, also true, because they're the same value and they're both strings. But 3, the string, triple equals 3, the number, is false. The triple equals built-in operator function says those two things are a different type, so they're not equal. So using the triple equals will prevent us from having some odd potential errors in our code when comparing values. So if I go back to my code, I'm going to shrink down the font size just a bit. And let's say I had a variable a, which is a 0, a number, variable b, which is false, a Boolean, two primitive types, and I say if double equals, right here, if a double equals b, I'll do an else, and then I'll say console.log, they are equal. And then I might say console.log, nope, not equal. If I use the double equals, these two values will be converted or coerced to the same value, and I get they are equal. If I use the triple equals, because they're different types, I get nope, not equal. So, what's the lesson? First of all, in general, try to do comparison against things in your code that you know will be the same type. And in general, I would say 99% of the time, use triple equals when making equality comparisons. Don't use double equals unless you explicitly, unless you consciously want to coerce the two values. You should start right now, if you haven't already, start using triple equals in your code by default. That's your initial go-to equality comparer. And use double equals only if you are aware of the implications and that's what you want to have happen. And of course, you can also use the strict inequality, which is not than the double equals. So regular inequality, not equal, if I put A is not equal to B, and I said they are not equal, if that happens. Otherwise, I'd say equal. Then, because this coerces the two values, same thing, that gets equal. This was false. This are they not equal was false, but the double, the strict inequality, does what I would expect. They are not equal. So when you see these values, don't get overly confused or concerned, because we've learned what operators are. They're just functions. This would be as if I had a function double equals, which took a couple of parameters, and this one coerced, and I had a function triple equals, and it took two parameters, and this one didn't. They're just two different functions that behave differently. And as it turns out, in production code in the real world, it's generally better to use this one. That said, it would be nice to at least have a reference for what's going to happen in these cases. There's a really nice link, again, over on the Mozilla Developer Network, developer.mozilla.org, called Equality, Comparisons, and Sameness. And it talks all about this. And it has, at the bottom, a really nice sameness comparison table, showing what happens when you compare two different types of values using the double equals, the triple equals, and something new that's coming in the next version of JavaScript called object.is, which is even a bit better. I've taken the liberty of converting this to a PDF document for you, and it's attached to this lecture. But you can just go to the website if you like and look up this equality, comparison, and sameness table. And you can see, for example, that 0 and false are when compared with double equals. That's true, that they're considered the same thing, but with triple equals, that's false. With object.is, that's false. And you can see that there are cases where it's true across the board as it's supposed to be. The object.is, and the way you use that is you pass the two values to the is function, object.is, so it isn't treated exactly like an operator. A positive 0 and a negative 0, although they would appear to be the same thing, are treated differently. So you can look at this table and get some idea of what the expected results would be depending on the values that you're dealing with. But that doesn't change the fact that for right now especially, triple equals is your best option. All right, so we've talked about operators and precedence and associativity, comparison and coercion, and we've seen how coercion can be bad. But let's talk about a case which is used in many popular JavaScript frameworks and libraries where coercion actually is helpful. How could all this dynamic typing and coercion be useful? Well, let's talk about existence and booleans. I have my DevTools open, and much like I used the number built-in function, there's a boolean built-in function to try to convert. Again, I don't recommend that you use these. However, they're useful for demonstration purposes. So if I'm converting to a boolean, true or false, some different values, let's see what happens. When I try to convert undefined to a boolean, undefined becomes false when it's converted in the JavaScript engine. How about null? Null is false. How about empty string? Empty string is also false. So all of these things that imply the lack of existence, they convert to false. Can we use that to our advantage? Yes, let's go back to our code. And in this lecture, and many of the ones beyond, you'll get this code downloadable. The previous lectures were just simple examples, so I encourage you to try them yourselves. But here we go. I'm going to set var a, and I'm not going to set it equal to any value. Let's suppose I have some code that I won't write that goes out to the internet and looks for a value. And if it finds it, then it sets a equal to that value. I can then say an if statement. Whatever I put inside the parentheses of an if statement, it will attempt to convert or coerce to a Boolean, true or false. So it doesn't really matter what A is. If I put it inside the if as the statement, as the thing I'm checking, it will attempt to convert it to a Boolean. So I can go console.log, something is there. If A, see that? A will be converted to a Boolean. So if I go back, if A is any of these three things, then this if statement will fail because A is nothing. Because remember, the creation phase of the execution context is going to set up the memory space for this variable, and then what is it going to do? It's going to set it to what value initially? That's right, undefined. And what does undefined convert to? False. So we can use this coercion to check if A is nothing. If A came back and ended up being undefined because it was never set, or A was null, when I was doing whatever logic I was doing, I'll still get nothing. If A was an empty string, this will still convert to false, so nothing will happen. But as soon as I have something, like in string that's not empty, then that runs. See how that works? We can use coercion to our own advantage and check to see if a variable has a value, something other than undefined, null, or empty string. Now there is one caveat. If I clear this, Boolean 0 is also false. So if there's any chance that this variable can end up being a 0, that's a problem. Because 0 is not necessarily lack of existence. Maybe that's a valid value. But A is going to be coerced when it's just like this, just by itself, to a Boolean. And so if I refresh this, I don't get a console.log because this is false. 0 became false. So I could do something like this. If I ever thought that was possible, I could do or A triple equals 0. So what's going to happen here? Well, if I check my operator precedence and associativity table, I have, when I scroll down, the or, logical or, and that has a lower precedence than strict equality. So this strict equality function will be run before this function, the or. So first, it will run this triple equals function. A is 0. It's not going to coerce. So if it really truly is 0, it will say this is true. And then this will run. The A will be coerced, and since it's a 0, it will be coerced to false, since or wants Boolean values. And it will say if false or true. And or, when I say false or true, returns true. If either one is true or both are true, this function returns true. So then this becomes simply true, and I should see something is there. So if I back this out, this phrase, these two functions run in order, should then result in something is there being outputted to the console, and it does. So all I'm doing here is saying if A is something, not undefined, not null, not empty string. And you may never need to do this, because if there's no real chance that this is going to be a 0, it may be perfectly fine to simply leave it as if this exists, if this even exists at all, if anything was placed into memory other than undefined or null or empty string. So that can be very useful. And this pattern of coercion, of using coercion in this case to check for existence, is used in a lot of really great frameworks and libraries a lot of really strong JavaScript code that's out there. It's very useful, and you can use it. Of course, if you're helping someone to debug their code that has seen this and is trying to use it without fully understanding it, and the if statement seems to be returning false when they're confused that there is a value in there, you could help them. Maybe that value is 0, and you could explain to them 0 converts to false. So that's why it's acting as if nothing is there when you're using it inside an if statement this way. So again, understanding what's happening under the hood and how all this is working will make you a better JavaScript programmer. You'll be able to debug problems better and also use advanced concepts like this in a clean, clear, and correct way. Let's bring together some of what we learned about operators with coercion and look at another way that these concepts can be used to our advantage in a pattern that's commonly used again in many libraries, frameworks, and other good JavaScript code. I again have a blank app.js file, and I'm going to create a new simple function called greet. And it's going to take a name as a parameter. And what it's going to do is simply say console.log hello, then name. And then I'm going to call greet, and I'll pass my name, Tony. All right, let's run this, and it says, hello, Tony. Pretty simple. But what if I called greet without a parameter? Unlike many programming languages, JavaScript doesn't care. This won't throw an error. It will simply pass nothing to name. So if I console.log name, and then this, let's see what happens. Look, kind of as we expected, right? Undefined. Because what happens when the function is invoked? A new execution context is created, and this variable, which is essentially created inside the function, though the value is passed during its invocation, is initially set when the memory space is set up to undefined. So JavaScript simply ignores the fact that I called the function without the expected parameters and simply says, that's okay. It's undefined. It's already in memory. It has a value, and you simply didn't give me a new one. And then that hello, well, look what happened there. That's a problem. You see, the plus operator, when it saw a string and undefined, that's the value in name, it coerced name, the undefined primitive type, to a string. And so it literally coerced it to the string undefined and then put them together, concatenated them. That is not ideal behavior. But it isn't totally unexpected behavior in that we now understand how operators and coercion works. But what should we do? What if I want a default value for this parameter? Well, the next version of JavaScript, ES6, is actually going to introduce syntax to set the default value. But if you look at current JavaScript code and a lot of legacy code inside a lot of software, you'll see a neat trick for setting a default value. So I can say that name equals name or, and then I'll put, let's say, your name here. Let's say that's my default value. So what's going to happen if nothing, if undefined, ends up being the value of name when the function is called? Well, remember that operators are just functions that return values. So what does the OR operator in JavaScript return when you pass different parameters to it? It actually does something kind of neat. It doesn't just return true or false. Let's take a look. If I clear this, what if I tried true or false? Well, it returns true. That makes sense. If I return undefined or hello, it doesn't return true or false, it returns hello. It returns, in this case, the value that can be coerced to true. Because if I coerce hello, a non-empty string, it's true. So that's what the OR method returns. If I put hi and hello, it gives me hi because it will just return the first one, that coerced to true. So the OR operator's special behavior, in that if you pass to it two values that can be coerced to true and false, it will return the first one that coerces to true. 1 can be converted to true. 0 converts to false when converting to Boolean. So I can use the OR to say, if something does not exist, or is an empty string, or a null, give me this back instead. Null or hello. Empty string or hello. See how that works? Operators are functions that return values. That's why I can use this line of code and say, well, name is equal to name, the value that I currently have, or some default value. And what will happen if name is undefined, or empty string, or null, then this OR function, this operator, returns the default value to this equals operator. So what will happen is OR will be run before equals, because if I look at my precedence, the assignment operator equals has a lower precedence than OR, so OR is run first. So OR is run. If this is undefined, I'm going to end up returning this value, and then the equals is run. So let me call greet twice. Greet Tony, and then greet no parameter. When Tony is passed, this will be true because it's not an empty string or undefined, so the string Tony will coerce to true, and that's what will be returned from this OR. So name will still be set equal to Tony, just set equal to Tony again. And the second time, this is undefined, so the OR operator will return this value, which will be set equal to name. So what would I expect to see? Hello, Tony, and then what? In the second call. Let's look. That's right. Hello, Tony, and then hello, the default value, your name here. So I use this one-line OR expression to set a default value. Now, I could have done this with an if statement, but that's a lot more typing. This is a pretty neat and clear trick that makes your code very readable when you understand it. Now, you still have to be careful with 0. If I was to call greet and pass the number 0, that converts to false also, so I'd get the default value again. So you do have to be careful about 0 again. But nonetheless, that's a side case. In most cases, this is just fine to do and is really a neat thing that you can do in JavaScript. It's time for our first framework assigned. I really like these. The idea here is that we're going to talk for a moment, and we'll do this throughout the course, about how what we've been discussing is used inside popular and famous frameworks and libraries that are used on millions of sites around the internet and in many web applications. For our purposes, although framework and library can really mean two different things, we're going to essentially talk about them as if they were the same thing. For our purposes, a framework and a library are the same thing. A grouping of JavaScript code that performs a task and is intended to be reusable. But we're going to dive deep into how libraries like jQuery or frameworks like AngularJS use some of the concepts we're discussing in their code. So let's talk for a moment about default values. We can combine some of what we've learned about default values and also about execution context in the global environment to understand some lines of code that appear quite often in popular frameworks and libraries if you look under the hood and look at their source code. So, for example, I have this index.html file that's just referencing app.js. I'm going to pretend that I have a couple of libraries or frameworks that I'm including in my project. So let's say lib1 and lib2 are two libraries that I have. Now, I'm going to go ahead and create those. lib1, lib2. And in library 1, just for an example, I'm going to go ahead and set a variable. Let's say I want the name of the library. So the library name, this is lib1. And this, suppose, is written by one person, and lib2 is written by someone else entirely, but they also create the library name, lib2, the same variable. So what's going to happen? Well, when you look at the app.js file, and I console.log library name, we need to understand what's happening when these three JavaScript files are run. These three script tags are not creating new execution contexts. They're not separating the code in any way. Quite literally, they're just stacking the code on top of each other and then running all of this JavaScript as if it was inside a single file. And often, when in production JavaScript environments, you actually combine and minify your JavaScript code into one file anyway. So it's important that these files not collide with one another. Let's run this code for a second. And let's see what we get. I'm going to go ahead and open my console window and look. lib2. So what happened? Well, what happened was that when looking at how the JavaScript source files were loaded, library 1 or lib1 was loaded as line 1, lib2 was loaded, so that's line 2 of the code that was run, and then console.log. This was all then treated as global variables sitting inside the global execution context, and thus attached to the window object in the case of the browser. So I declared var library name, and that was attached to the window object, and the second var just replaced it right over this first library name. So this can be a bit unusual when dealing with frameworks or libraries. Maybe we've accidentally collided with another library, or maybe another library is there to replace us. So we want to be nice about this. What can we do? Well, let's go to lib2, and we can check and see if library name is already in the global execution global variable. So I could say window.libraryname equals, and then I'll say window.libraryname or lib2. So what am I doing? I'm checking to see if there's already a library name in the global execution context sitting on the global variable, which is window. If it is, then I'm just not going to do anything. And if not, using the OR operator to set my default value, because if this wasn't set by anyone, it'll be undefined, then I'll set it to the value that I want. So if I run this code, it's lib1. See that? Because this first JavaScript file, that's the line that was run. This is put onto the window object. And then in my second library file, I just made sure that I wasn't colliding with it by checking to see if something was already there of that name. So in the case of a lot of frameworks and libraries, you'll see a line of code that looks something like this, where it's actually setting the object or the set of functions that define the library or the framework, and not bothering to do anything at all if something is already there of that name. Now, of course, this could in itself cause some errors, but that's likely the developer's fault for perhaps colliding with the name that's already in the library he or she is using. And it makes it easier to debug and understand what's going on, because the entire library just won't be there, because it will say, oh, you've already used that name, so I'm going to exclude myself from doing anything at all. So when you look inside the source code and you see something that looks kind of like this, understand that it's checking the global namespace or the global object to see if something of that name is there so that it doesn't collide or override it. It's time for a new section of this course called Objects and Functions. In a lot of JavaScript courses, they treat these two concepts as two different subjects to teach. I think that's a big mistake, because while in other programming languages, objects and functions are two distinct things to talk about, in JavaScript, they're very, very much related. They're really, in many ways, the same subject. So let's talk about objects and functions. The first subject, or the first topic we'll discuss, is objects and the dot. Remember, we've already said that objects are collections of name-value pairs, and those values can then be other collections of name-value pairs. But for our purposes now, let's look at objects from a little bit of a different perspective. Let's think about how an object lives or resides in your computer's memory. An object, like we said, is a collection of values that are given names. But what values are we talking about? Well, an object can have properties and methods. So an object can have a primitive sitting off of it, and that would be called a property. Remember those primitive types that we talked about. So any one of those, like a Boolean or a number or a string. An object could have another object connected to it as a child, so to speak. And this is also considered a property. Remember, we said the value could be another name-value pair collection, or that is, another object. An object can also contain functions, and in those cases, the function is called a method when it's sitting on the object. So it's still a function, but it's connected to an object, and so it's called a method. So objects have properties and methods, and these sit in memory. So the kind of core object will have some sort of address in your computer's memory, and it will have references to these different properties and methods which are also sitting in your computer's memory. Now, they may be related to the address of that base object concept, or they may not, but either way, the object has references to the addresses or the space or the spots where these different properties and methods live, and those addresses might look something like that. So this may seem a bit obscure, but it's important for things that we're going to talk about later, that you think about an object as sitting in memory and then having references to other things sitting in memory that are connected to it. So it knows where its different properties and methods are. That is, primitives, objects, and functions that make it up. All right, so let's look at, in JavaScript, how we access those slots in memory, those properties and functions of an object. All right, so I have an empty app.js file, and I'm going to create our first object, var person, and I'm going to use the syntax equals, and instead of a primitive like a string or a number, I'm going to say new object. Now, let me be clear. There are better ways to do this, and we'll cover them shortly. But just for this moment, I'm going to use the new object syntax to create a new object because it's very obvious what's going on. So I'm creating a new object, and this is going to sit in memory. Now, I'm going to add properties and methods. So, for example, I can say person, and then I'm going to use what's called the computed member access operator. That's right, an operator. The operator is this, brackets. And inside those brackets, I put the name of the value that I'm trying to locate in memory. So let's say first name. It doesn't exist yet, so when I use the equals, Tony, it's going to create that spot in memory and give it that name, and this object will get a reference to the address of that location in memory. So it will know where first name is in memory, and that's going to be a primitive, a string. So it's called a property, the first name property. So this is one way to set and access properties. If I go back to my PDF of JavaScript operator precedence, you'll see that we have computed member access. It's very near the top, and it's left to right associativity, and it's brackets there. So this is an operator. What the operator does is it takes this object and this property or method name, and it looks for this on this object. It actually can do quite a bit more than that, but we'll see that much later in the course. But for starters, this is one way using a string to access this. So let me set a last name. Now, the neat thing about this operator is that I could set a string, let's say first name, and I can then use that string to access that property using that bracket notation or that operator. So let me first of all just log the person itself so you can see it, and then I'll log person. I'll use this bracket operator, and I'll pass this string, this variable that contains this string. And remember, this operator will take this object and look for a property with this name. So this name is first name, so it should find it. And what should it output? Tony. So let's go ahead and run this in the browser. And then I'll open my console, and there I see Tony. So the computed member access operator, those brackets, worked. They looked at the object as one parameter and that string as the other parameter and went out and found that property on that object and gave me the value. Notice I also just outputted the object itself, and I can see those two properties, first name and last name. There's another property, this underscore, underscore, proto, underscore, underscore. Don't worry about that right now, but we are going to get into that later in the course. For now, we'll just focus on these that I've made, first name and last name. And I've outputted the first name using that special operator with the brackets. So let's go back to our code, and let's talk about another operator, the more common operator and clearer and easier to type operator for accessing properties and methods. Now this approach here that we just talked about, you will see sometimes in frameworks and libraries, because you can dynamically decide what property you're trying to get. You can base it off a string. But it's much clearer and easier to type the next one. All right, I'm going to console.log the first name again, but I'm going to use a different operator, the dot operator. And it is just what it sounds like, dot. Then I can say first name. The dot is an operator, it's a function. And when used after an object like that, well, if I go back to my JavaScript operator precedence PDF, you'll see it's just second from the top, right after the parentheses for grouping. It's left to right, and it's just a dot. And it takes two parameters. the object that you're looking at, and the name of the property. Notice I don't have to put this in quotes or something, although that's essentially what it's doing. It's taking the object and passing the string that represents the name of the value that you're looking for. But I don't have to do that. That's not really accurate. You can't do that. It will simply, the syntax parser will understand that after you put the dot, what you've actually typed will be the string that's given to the dot. So that's just a lot faster to type. Person dot first name. And if I run this, since I'm already outputting the person and first name again, I'll just get the first name again. So I refresh and there it is. See that? So the dot operator acted exactly the same as the brackets operator here. This is computed member access, and this is just called member access, the member access operator. Members being members of the object, right? Your fingers and your toes are members of your body. So these are looking for members of the object, the pieces, the methods, and the properties. So this went out and found this property because it's just a string. It's not called a method, it's called a property. Okay, so I could console.log person.lastname. Very readable, very easy to type, and that's what's really happening. It went out and found that memory location, that reference by name that's connected to that object. And I could have set this value as well the same way. In fact, remember that the other type of property you can have as opposed to a primitive is also another object. So I can attach another set of names and values. Let's say that person.address. I'm going to make that, instead of a string or a number or a Boolean, I'll just make it another new object. So it's an object sitting inside an object. And then I can use the dot operator, for example, and add properties to my sub-object, my child object inside of here. Now remember, these are operators, so how do we know which one gets run first? Well, we go back and we see that the associativity of the member access operator is left to right. It has left associativity, meaning that the leftmost dot will get run first, get called first, because they're functions, and then moving on to the right. So this one, between person and address, gets called first, so it says, okay, I'll look at the person object and look for a property or a method that has that name. And then it finds that in memory, and then this second dot operator is called, and it says, okay, on that thing, on that object that I just found in memory, I'll look for a property or a method on that called street. Now in this case, it won't find it, but I'm setting a value, so it will create it and give it that initial value. And I could just keep doing this. So I might have address.city, let's say New York, and state, let's say New York. And you can see I could make this other sub-objects and sub-objects and sub-objects, and I could just keep going because it's a left to right dot operator, left associative, and the objects can keep containing other objects, which can contain other objects, which can contain other objects. So this is very powerful. And realize that the objects themselves and their properties and their methods are all just sitting in memory. These dots and these brackets, passing strings to them, they're just functions. They're just operators, a way to access that information. So now I have this object sitting in memory. I could do a person.address.street and output that, and it'll go find it in memory running those two different operators. I could go person.address.city, and it will find that. And I could, on the same object, just use a different operator. So I could go address using the computed. This is also left to right. If I look, it's left to right. So I can also then just do another one. So let's say state. This is essentially doing the same thing. It looks at the object, finds a property or method called that, runs this operator first, then the second operator, it'll look for a state property on that. And the dot is doing the same thing. And they're both simply accessing the same memory locations via the same names. So they're just two different functions that are essentially doing the same thing, and I refresh, and there I'm outputting my values that are sitting in memory using both operators. So again, objects are name-value pairs sitting in memory. They can contain other name-value pairs, that is, other objects. They can contain other properties, strings, booleans. They can contain numbers. They can also contain functions, which are called methods, but we're not going to quite get there yet because there's a couple other things we need to understand. But good enough for here. Remember that this is not the preferred way to create a new object. We'll get to that in just a second. And also remember that although we can use the dot or we can use the computed, the bracket notation here for finding properties and methods, the preferred approach is just using the dot operator. It's very clean, it's very clear, and it's also easier to debug and find problems. So I always recommend that you use the dot operator unless you really need to access a property or properties using some kind of dynamic string, some kind of string that can be changed, that you can look at programmatically. But to start with, always use the dot operator. That's objects in the dot. Remember how we said when we typed new object that that wasn't the best way to create a new object? Let's talk about objects and what's called object literals. So we're back to my blank app.js file, and we're going to talk about object literals. In JavaScript, there are often more than one way to do something. So we already saw that I could create a new object by going new object like that. And we'll talk a bit more about this later in the course as far as what it really means. But there's a shorthand for this called an object literal. And it's just curly braces like that. That's the same as new object. So if I console.log person, and I'll just run this, go to the console, you'll see that it's an empty object, just like when I said new object. So this is shorthand. Notice this is not an operator. What's happening is that the JavaScript engine, when it's parsing the syntax and it comes across this curly brace, and it's not part of something like an if statement or a for loop or something like that, it assumes that you're creating an object. And so I open and close this brace, and now I have a new object. But I can do a lot more than that. I can initialize the object. I can set up properties and methods all within these curly braces on what is essentially treated as one line of code. So for example, I can put the name of the property or method, then a colon, and then the value. So a name-value pair. I can separate those with commas and put another name and value pair. So now I have two properties on my object. If I console.log this and refresh, there I have my object with its two properties. This is essentially the same as saying person equals new object and then manually setting one at a time these individual properties. Notice I can use double quotes or single quotes for strings in JavaScript. These two things, this and this, are the same, but this is much faster, much quicker to write. So I can actually then create that object that I initially created in our last lecture. And it's often good to use white space. JavaScript is very liberal about letting you use white space, that is, spaces and tabs and carriage returns, and this is still treated as one line of code. but it just makes it more readable for me as a human. So I can add another comma, so we separate each name-value pair with a comma when we're using object literal syntax. And I could give it that address, but this is another object, so I just make another object with curly braces using the object literal syntax. And then I can do exactly what I did last time, separating with commas, giving the name and the values. So what's happening is the syntax parser and then the JavaScript engine, the rest of that process, when executing this code, when it hits this line of code, and again this is treated as one line of code, then it sees the curly brace. It says, you must be creating an object. And it looks for these name and value pairs separated by a colon. And if it sees another set, or even within another set, etc., of curly braces, that just means another object. So I can drop an object in wherever I want and define its properties and methods on the fly using the syntax. And so if I output this to the console, you can see that I have my first name, my last name, and an address property. That's an object itself with city, state, and street. A lot faster than defining all of these one at a time on separate lines of code. So this is a wonderful way and the preferred way to quickly create an object. It gets even more powerful, though, when we look at how the engine treats this shorthand. I can create an object anywhere that I can create any other variable on the fly. Just like I could pass a number to a function or a string and create it on the fly, we can create an object on the fly when passing to a function, for example. Let's show an example. Let's say I have a greet function that accepts some person object. And this person is going to be Tony right here. And let's say the greet says console.log hi plus person.firstname. So I have a function that expects an object that has a first name property. So I could call greet and pass Tony, and I should see hi Tony. And I do. So this object that was created and sitting in memory is passed to the function, and it's able to be used. But I could call the greet function and create an object on the fly. So maybe I wanted to say first name Mary, last name Doe. Notice I separated the name value pairs with a comma, and the name and value is separated with a colon, and the whole thing wrapped inside curly braces. I'll zoom in a bit on the code, just a bit, just so you can see this better. See that? And I could even use then some white space just to make my life a little bit easier when reading this. So that looks a little strange, doesn't it? Looks a little weird if you've never seen something like this before in other programming languages. But in JavaScript, I can use object literal syntax, and what's happening is the JavaScript engine sees that, oh, you're calling a function, and oh, what are you going to pass to it? Well, I just saw a curly brace, so I know you're creating an object right here at this moment of execution and passing it. It'd be no different than passing anything else, like a number or a string. You're creating that string on the fly when the function is called. And in this case, I'm creating the object on the fly. Wherever I want, I can create an object as I go. And I can use this object wherever I'd use any variable. So in this case, I should see what? Well, I'm greeting and I'm passing this Tony variable, which contains first name. And then I'm calling greet again with a different object, this one created on the fly using object literal syntax, and the first name is Mary. So what should I see in the console? two greetings. Right. Hi, Tony. Hi, Mary. See how that worked? And notice that I can mix and match this syntax. I could take this variable Tony and add a new property using the dot operator instead of an object literal, and then use an object literal to define it as some sort of object. So I'm mixing and matching my methodologies. So why does this work? Well, because remember what we said. The code that you write, the physical code you're writing, isn't what's really happening under the hood. It's being translated by the JavaScript engine into something the computer can understand. So the syntax, whether it's object literals, or you're using the dot operator, or you're saying new object, whatever's going on, it's all doing the exact same thing under the hood of the JavaScript engine. It's creating this object in memory and its properties and methods in memory, and that's it. So the syntax that I use doesn't matter because in the end, I'm actually creating the same thing. The JavaScript engine behaves the same way in both cases. So it's just a matter of what syntax would you like to use. And as it turns out, object literal syntax turns out to be really powerful. It can make for some very clean looking and easy to write code. So this is the object literal syntax, using these curly braces to define name and value pairs separated by colons. All right, let's move on. Hi, I'm Tony Elisea. If you're not interested in the rest of this 12-hour advanced JavaScript course, I completely understand. I hope you found the first 3.5 hours useful, and I wish you the best in your programming efforts. If you are interested, check out the links below for coupons or head to learnwebdev.net. And the rest of this course will build on the knowledge that we've already gained to have a clear understanding of first-class functions, callbacks, closures, immediately invoked function expressions, call, apply, bind. We'll dive into prototypal inheritance, function constructors, object.create, and the new ES6 classes. And we'll cover all of this by understanding how it's working under the hood of JavaScript engines. We'll also dive into the jQuery source code to see how we can get an open source education by taking our JavaScript knowledge and using it to read the source code of famous frameworks and libraries to see what we can learn. We'll take all this knowledge and build our own mini framework or library at the end of the course, and along the way and in bonus lectures, we'll look at the new things that are coming to the next version of JavaScript. So I hope you appreciate, as I do, that it's better not to just imitate other people's code, but to understand how things are working under the hood to make you a better developer. So, again, visit learnwebdev.net and happy coding.